Okay, second day of IFC, and we have a three-paper session, starting with David Fierro with the functional ambisonic granulator. So David Fierro is working with the Paris 8 team, with Alain Bonardi, Paul Gutmann, yes. And this is a work on granulation and ambisonic, so it's somewhat something that can be compared or discussed with what was presented, the first paper of yesterday of Pierre Lecomte. David.
Hello. Okay, so yeah, I'm going to present the functional ambisonic granulator. First of all, a little bit of contextualization. We work with the BBDMI project, which is an A&R project, which is Body, Brain, Digital Musical Instruments. And our lab is the CICM at Paris 8. So just to contextualize a little bit before we start, the BBDMI project, it's a project that it's meant to create music with the electricity of the body and the brain, so electromyogram and electroencephalogram information. So we are proud to say that every object that we have it's coded in Faust, from calibration, feature extraction, control processing, macro controls, sound synthesis, and sound effects. Everything is coded in Faust, and it's available in this link, so you can freely download it. And the webpage of our project, it's the one that is down below. So today we're going to talk about the architecture. Yes. The architecture, then the spectral processing that is inside the granulator, then the spatial processing, and then the macro controls. So first of all, in GUI, so the one that you have up there is the GUI that it's shown directly in the IDE of Faust. The one down there, it's a modified Faust compiler that we have. It's also in our repository. So you just have to replace the Faust2Max object, and it will generate an interface that looks a little bit like the IDE for Max MSP. So you can just replace the files of the compiler, and it will generate this kind of interface. The one that we're going to be looking today is the one to the right, which is just a B-patcher for Max MSP, which has just one functionality that is especially important for us, which is this button up there, which is the random button and the dump button. We will see just in a second what they do. This option here is a number of channels. You can use it as a multi-channel effect, but it's thought to be an ambisonic effect. So if you have your order 3, well, then you will use 7 channels, 11, etc. This on-off is just to turn it on and off. So before we start, I would like to just show you a little bit how it sounds, just so you will get an idea of what we are going to be talking about. So first of all, I'm going to show you the raw sound. I just did it yesterday with my Mac, so the sound is not very good, but it's just a test sound. So it sounds like this.
Test, test, 1, 2, 3.
So that's the test sound. I'm going to be just looping it inside the granulator. And I'm going to explain it later, but this is just a machine learning algorithm that is going to be morphing all these 16 parameters from one configuration to another from 1 minute. So we're going to hear what it does for 1 minute.
Test, test, 1, 2, 3. Test, test.
That's just a little test about sound configurations. As you can see, it has 16 parameters. So, I mean, you can go everywhere with that, but there's just some testing parameters. Just to talk a little bit about this dump button down here, it's something interesting because as we put it in hands of users, they have a little bit of trouble to play with all these 16 objects and find something interesting. So I just added a random button in this patcher. So just click here, and it will just randomize every parameter. So people will hear, and if they like what they hear, they just click on the dump button here. They dump the message. And this message, all you have to do is just to click it. And as you can see, all the parameters change immediately. So if you like something, you dump it, and then you just select it, and you can just start working with in your piece with that object. Okay, so this is the simplified diagram. We're gonna go through item by item. So the first thing is the filtering. So you have the two variables, high pass filter, low pass filter, that are gonna be just filtering the signal just before we start working with it. We're gonna filter it just to prepare it how we want it. And we see in this little red, the index distribution and the variability. We are gonna be affecting all the instances of the granulator. So as I said before, it can only be used as a multi-channel, but it can also be used as an ambisonic effect. So it means that the first channel is gonna have slightly different parameters than the second one, and slightly different parameters for the third one, fourth one, etc. And the way that we're gonna distribute all those parameters are gonna be controlled by this index distribution function, which is the one that Paul and Alan talked yesterday, and we're gonna see the functions in a moment. And the variability just means that if its variability is set to 0, all the instances have the same values. If the variability is set to 1, all the variables that we're gonna be looking today are gonna be changing a lot between each instance. So this is the filtering part. We just filter the signal, and then we go into the feedback loop with delay. This part is important because before we start chopping the grains, we are going to be mixing the signal with itself. And that's why I called it the functional ambisonic granulator, because it's really thought with the functional logic. So I really wanted like to play with feedback loops, mixing things, following like the river logic of functional programming. So first of all, we're going to just be adding a little bit of delay, putting the signal, mixing it with itself. And with that, we're just going to have a mixture of the input signal with the pass of that signal. So we're going to create a mass of sound before we start working with it. After we do this feedback loop with delay, we're going to be working with the envelope. So that's where we are going to be chopping the grains. We explored many different grains, but I just finally stuck with two envelopes. The one that I like the most, which is the easiest to do with Faust, but I don't see it anywhere, so I find it interesting, is the one that when you put this grain f morph variable there to 1, you will get this logarithmic one. And the other one that sounded good enough was the Gaussian also. So you can just, with the float, just control how you want the morphing of that envelope. So you can morph between all those parameters. Then we have the size of the grain and the spacing between them. I used a different logic from the rarefaction. So I prefer to say, okay, what's the minimum size, which is controlled by the grain size variable. So that's the minimum size of each grain that you're going to be generating. The grain offset is just an offset that you will be adding to each grain, and depends directly from the variability. So if the variability is high, in this example, we have 40-40, you will be getting grains from 40 to 80 milliseconds and running like that every time. If you set the variability to 0, you will be getting grains of 80 exactly. And the spacing is also controlled by the variability, and it's just the space between each grain. So if you set it to 0, you will just get consecutive grains. You set it to 1 second, you will just get 1 grain every second. And so with grain envelope, grain size, grain offset, spacing, you will be already creating all the grains with the specific size, a specific spacing between them. So after we cut every grain in envelope, then we start modulating them, each one. So there's a variable called the mod factor, which at 0 is just no modulation, 0.5, a little bit of modulation, and 1 is completely amplitude modulation. So you can just really regulate each grain at a time, also controlled by the variability. So each grain has a little bit of different modulation from the last one. Then we had the variable modfrec, which is just the frequency of that amplitude modulation. So now we have a modulation of 100%. So you can see a little bit of what does 10, 20, and 40 hertz. So it's just controlling the frequency of the modulating signal of each grain. Then we have another variable that it's called the mod morph, which is morphing the modulating signal that we are using. So in this image that I showed before, we are just using a sinusoidal here, but you can morph it from a sawtooth, square, and sinusoidal again from 0 to 3. It's a floating value. So you can mix, down here we have like a mixture of waveforms. You can have between a C-tooth and square or a sinusoidal or whatever you want. So it's just a floating value. Something interesting is that we at the beginning, we started using just a sinusoidal or just one phaser to control the modulation of each grain. But the problem of that is that the brain just gets the signal that it's controlling that. So you just hit all the grains and a pitch under it. So the solution was just we create the modulating signal every time we create the grain. So every time the grain starts, we start the phase of the modulation, which means that every grain is going to be decorrelated. So we can hear the modulation, but we don't feel like one pitch is over it. Then we have the frequency modulation of the amplitude modulation. So here in the 0, for example, you have the same modulating frequency, but it starts with a high pitch and it starts with a lower pitch, which does kind of a dew effect. With 1, you start with a low frequency, you go to a high frequency, but it's go like a tew. You know, you can, with the FX7, you know kind of what it sounds. And it's controlled by the mod-freq mod. So 0.5 is just no frequency modulation of the amplitude modulation. After we do the modulation, we are going to just be transposing the grains. Very simple step. We are just going transposing in high or lower pitch with a 24 semitones, so it can go really, really far. And after that, it comes the spatialization part. This part has 2 ways of doing it. So we have 2 implementations. The first one, which is kind of what we explore the most in our lab, is the spatial sound transformation, which means that we are going to be transforming the sound with a modification of an spatialization algorithm. So in this case is Ambisonic. So as you can see in this example here, what I have here is just an encoder, an Ambisonic encoder. Then I put it to every channel. So I'm going to be chopping and modifying every channel of that circular harmonics. And then I'm going to decode them. So this is the first example that we have here. Okay. What it does is that the decoder, instead of having the perfect image that was encoded from the Ambisonic encoder, is going to be deformed. So as Paul and Alan talked yesterday, if you just add a little bit of delay, the decoder doesn't have the complete image. So it will just try to recreate the spatial field, which generates kind of a diffuse field or a decorrelation. So with the small values, you get like maybe filters, filter, etc. But with high values, you start getting like rhythmic parameters. So you will always be getting like a diffuse field. Of course, what we are hearing today is just a stereo output. Normally, it should be here, we know, in an Ambisonic setup with 4, 8, or 16 speakers or more. So this implementation helps us to do an independent manipulation of each Ambisonic harmonic, which are going to be controlled by the index distribution that we're going to take a look in the next slide. And the other way of spatializing that we have is the from point source to diffuse field. What we do here is that we just, every time we do a grain, we just encode it in the Ambisonic space. So we put it there or there or there in a random position. But as we're going to see in the next slide also, we added a feedback loop, which means that the first time you hear the grain, it's very spatialized, in a position in the space. So you hear it there or there. But the second time the grain comes back, it will have all the harmonics delayed or modified. So you won't get a one position, you will get just a diffuse field. So you hear tick, 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 tick. Every time you hear the first time it's well positioned, next time it's just a diffuse field and it goes on and on. So this is the famous Ambisonic distribution, which only what it does is there are 22 different easing functions, the one that Paul and Alan talked yesterday, which, for example, just analyze the first one, X, so it's a linear distribution. For example, if we take the grain offset, that means that the first grain will have a little bit of like 10, the second one will be more 20, the second we add 30, the fourth one 40, etc. If we use the sinusoidal, for the first one we'd add 0, then 20, then 40, then 20, then 0, then 20, then 40, so it will be oscillating. So it's just how we are going to distribute all those parameters that we talked before between each instance, which is a channel or an ambisonic harmonic, depending on how you use it. Then after we have the spatialization, we are going to be doing the feedback loop with transposition. This is what I call the grain collector, which is we take a look up until here in this entrance here, we have every grain, just a single grain, transformed, modified, transposed, but it's just single grain going out. What I wanted was something that was giving you like a mass of grains, you know, a mixture of different size of grains. So what we do is that we just put it back in a feedback loop with a delay and the transposition. This transposition has two advantages, let's say. So, well, the first one of this whole loop is that instead of having just one grain at the output, we have a mass of grains. So we have little and big grains, medium grains, more modulated, non-modulated. All those grains are just mixing together and we just get the whole result of that. And the second important thing of this feedback loop is this transposition, because as you can see, the transposition is not set like in the other transposition in the first linear output. Is being used in the feedback, which means that what is going to be transposed are the echoes. So the first time you hear it, book, and then if it could go for the high pitch, so or it can go tuk, 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 tuk. You know, the echoes are going to be just leaving to the low frequencies or to the high frequency. And it's controlled by the trans-out variable, which also it's modified by the variability and index distribution. And then we have the macro controls. So the first one is the one that we just saw at the beginning, which is the Rapid Max object that was not developed by us. So it's a Rapid Max object, which is just a regression algorithm. And a one-layer perceptron that was coded in Faust. We haven't been able to train it. We are going to be using Tommy's implementation to train it. But for the moment, what we have is just a one-layer perceptron that gives us the possibility to control all those 16 parameters with just one or two inputs in a non-linear way. So it just gives interesting results. So if we go back to this MaxMSP patch, I'll take my time. This is the Rapid Max object, which is here to the left. What it's doing, it's oversimplified because we only have like the time as an input and 16 variables as an output. So I'm just doing like, as you can see here, I'm just morphing between different photos that I took. So we'll be just modifying all the parameters in real time. A moment ago, we heard how it sounds, but I'm going to be just clicking in these messages here that I got just by clicking in random. And when I liked it, I just click in dump and I copy the message. So I'm just going to show you a little bit of extreme situations where we can go. So at the beginning, we kind of heard the sound. But when you go in extreme situations, you add a lot of modulation, a lot of transposition, a lot of everything. You kind of work with like a sound synthesizer instead of a sound effect because it changes so much the sound. So I propose you to just hear the sound. I'm going to play again the sample sound.
Test, test, 1, 2, 3.
Well, so that's the training sound. And we are going to be using the Granulator now. And I'm going to click in with this picture. Just a mostly like random picture. Now I'm going to click in the next photo.
Test.
Okay, third photo. There's a lot of modulation there. And the fourth one. And now I'm gonna play again the moving picture. So from one state to the other, we changes also the result because we feel like the morphing of all those signals. So now let's go from 0 to 1 again. Okay, so that's how it sounds. And yeah, last thing. So this patch that you have here has all the explanation of the same images that I put in the paper. So you have a little bit of explanation of what they do. You can click these banks to just hear what they, so little spacing, a lot of spacing and everything. And they are also freely accessible in our GitLab repository down here in the Faust folder. So you will have, well, that one is in the Max folder in the Instruments Spatial Granulator. So you can have the complete code and see how it works. Yeah, so that's 22 minutes. So maybe we can have some questions. Thank you. No questions about it? Okay. Oh.
Thank you. Very impressive. Do you have the same? Sorry. Thank you. Very impressive. Do you have the same problem of decorrelation of noises of random generators? And what, maybe it's a question for also for Pierre, what should we do into Faust to improve the situation?
Yeah, I had also the same problem. And the solution I implemented was something, again, inspired by you and Romain. And what I'm doing is just I'm overloading here. I'm using a random value that I'm overloading in the maximum integer value. And I do a feedback loop. Then I divide it by the maximum amount of integer values that we have.
Okay.
And then just I normalize it. So that will give me a value between -1 and 1. And in order to decorrelate them, I'm using an index that you have here. So the first index, well, this is an old implementation. Now I'm not using it like this. Now I'm using it with an input value, and then I call it. But here I just needed two noises, separate noises. So I just put an index and an index multiplied by 20. So
Okay.
each channel has an index of 1, 2, 3. So I guarantee that between channels they are different, and also between these two noises they are also highly decorrelated.
Okay.
But it's kind of the same seed. Yeah.
Okay. So we need at some point to discuss of introducing a random primitive in Faust. I think it would be great. Can I have a second question or no? Okay, thank
Please.
you. So in the examples, you have one sound which start to be one grain which start to be well localized, and then at the second and the next iteration, it start to be all over the sound field, so to speak. And this is possible because you do a feedback loop.
Yes.
But at the same time, it's super interesting to have the reverse effect, which is to start with something very distributed and then converging to one location. But you can't do that with a feedback loop.
No.
So you need to simulate with many in a fair, so to speak, way to do that, so that you. And I'm wondering if there is any possibility to do that in.
Good question. But as you say, it's a little bit harder because it's very easy just to decorrelate and they will just go diffuse field. I haven't thought about it to do it that way. But as you say, I think that we'll have to simulate it to use the sound, create a diffuse field, and then bring back the really well encoded signal. But yeah, it was not the implementation I did, because this one is simpler.
Okay, thank you.
Thanks to you.
You probably have to come here.
Thank you for a great talk. Just interested in that single layer perceptron. Can you just remind me what that is, what role that's serving in the system?
Actually, what it's doing is just, I'm going to show you maybe the patch would be easier. I don't have it here. Wait a second. So what it's doing, I'm just going to take 1 second and I'm going to show it to you. I'm still working on it now. Yeah. So what we're just doing is, for example, here, I'm just putting random weights and biases. This is just the 2 inputs of the perceptron, and these are the 16 outputs. So what I'm doing is just to get 2 control inputs, and I have 16 or whatever amount of outputs I want, which are not linear. And if I change it randomly, because I can't train it yet, with this button, you will see that at this point, I have a phaser as an input. And as you can see, there's not phasers going out. They are kind of non-linear. If I click here, you get just a different, for each output, completely different range and waveform. So that's what I'm doing. I'm just using 2 really inputs to modify the 16. But again, it's just a random weights and biases.
Okay, so is it multiple? It's multiple neurons.
Yes. So
these are implemented in Faust?
Yeah.
Okay, cool. Yeah. I'd be very interested to see what your implementation is and how it would compare with some stuff that myself and a Google Summer of Code contributor worked on. But in terms of creating something that you could use in what's the word? An optimizable or a learnable way. I think we should definitely have a conversation about that today at some point. I think that'd be really very interesting.
Perfect. Thank you. Yeah.
Cool. Thanks.
Yes.
So next speaker will be Yann Orlaret, speaking on another new feature inside the Faust language, which is widget modulation.
this is my screen? No. Okay. Okay, it's working. Thank you. So it's not going to be unrelated to what we just, the previous presentation. And so I'm going to explain this new feature called the widget modulation, which is not really new because it's already into Faust since several months. Okay. So what I'm going to present is the concept is not at all new because it's modulation like you have in any analog synthesizer. So what I'm going to present is a way to introduce modulation without having to rewrite the code of an existing circuit written in Faust. For example, and by the way, I'm going to use the same library that I used yesterday, which is called the modular.lib. It's not already part of the standard Faust library, but we'll probably introduce it, and we will welcome contribution to that library. So here, for example, I have two VCO, and obviously these VCO have no inputs. So how can I use one VCO to modulate the frequency of another VCO? And this is the point of this widget modulation. The idea is that we don't want to edit the code. We have a library. Someone provided that the definition that libraries, and we just want to use that library. We don't want to copy the code, edit the code to introduce new entrants. We want the compiler to do that for us. That's the point. Basically, here you see that we introduce here this notation, which says basically, okay, I know that in this VCO there is a widget called FREC, and I want to modulate this FREC control. I want to create an additional input to my VCO, and I want to combine using an addition between the value produced by the widget and the value produced by this new input. Okay, so here is another example. The interesting point is that as the creator of the library, you don't have to think of the modulation that the user of your library is going to want. And this is completely, for example, here, we will see that we will modify the user interface of the free verb. Okay, for example, here, you can just remove a slider by replace it by saying, okay, the wet is going to be replaced by a specific value. So now the wet slider has disappeared. You can also make disappear the room size, for example. And you can even here replace a slider by another one. So for example, here I have this stereo slider, and I said that I want to replace the stereo spread slider by this new side. So you can, basically, you can remove code, user interface code, and you can inject code in that point. So it's again, like I was saying yesterday, a kind of new operation on circuit itself, because the compiler modified the circuit for you. Okay, so what is the syntax of this widget modulation? So you see that it starts with square brackets. And then you give a list of targets separate with comma sign, and then this arrow sign. And a list of a target, what is a target, is basically a widget path, a way to identify the widgets that you want to modulate, and an optional modulation circuit that you want to insert in the code. So if you don't specify a modulation circuit, then it's going to be a multiplication. But in many cases, you want to specify the way the two signals are combined. So the widget path is basically the name of the widget, but it can also include some of the surrounding names of the surrounding groups that lead to that. If let's say you have a complex user interface with many FREC sliders for each different channels. If you just specify FREC, then all of them will be matched by your specification. But if you want a specific one among all these, you need to introduce enough group names to identify uniquely the one that you want to control. Is it clear? No, more or less. So this is expressed here. And when you introduce group labels, they don't have to be consecutive. It can be anyone. You can give one of them and two of them, etc. They don't have to be consecutive. Just what you want to do. How to specify the widget that you really want to modulate. Okay, and then there is this modulation circuit that you want to introduce. Again, you can have three kinds of modulation circuit. A circuit with two inputs and one output. In this case, an additional input is created into your circuit. And you explain how you combine the original value produced by the widget with this additional input. By default, it's a multiplication. You can introduce a one-to-one circuit. In this case, you introduce a modification, a transformation of the value produced by the slider. For example, here, I say, okay, I want the wet slider to be multiplied by the value introduced by an LFO. And you can also have a 0-to-1 circuit. In this case, you just say, okay, I just want to completely replace the widget by something else. For example, an amber. So here is an example of that I was using yesterday of a modulation circuit that combine the slider value, the widget value, with the modulation signal. And it's basically that it uses the lowest and the highest possible values of the signal produced by the widget in order to do the modulation. So it's basically, it says that if the modulation signal is 0, then we don't want any modification. If the modulation signals goes to 1, we want the full modification from the current value of the slider to its highest possible value. And for -1, we want the reverse. So it's one possibility of millions of modulation circuitry that you have. The important point is that you can add your own modulation circuit. So to conclude, what's nice, in my opinion, with this extension is the fact that it pushes code reusability to a new level. Currently, you have to have two different versions of what you provide in the library. You have the algorithm without user interface, and you have a demo version with a full user interface. But there is no choice of either you use the algorithm and you reconstruct the user interface that you want to use, or you use the full user interface provided as a demo. There is no, you can't blend between the two options. And with widget modulation, this is exactly what you can do, and you don't have to look at the code. And it's just have to look at the user interface to know the name of the widget. That's all that you have to know. So I hope that with this technique, we can create this kind of modular synthesizer library that I'm going to show you briefly. Okay, so probably too small. Is it okay? Okay. Okay, so this modular lib has several modules. So a bit generator, a DSR, another kind of envelope, LFOs, VCO, VCF, clocks, Euclidean, etc. So I'm going to here make a short demo. So let's okay, so this is my yes, because you need to turn the volume, sorry. Okay, so it's normal. You can choose the type of wave. Okay. Okay, now I want to, for example, place this into a panel. Oops. I need to put in real-time compile. Okay, this is my panel. Okay, now I would like to change automatically the position of the panel. So how can I do that? I'm going to modulate the pan value using an LFO. So here I use the square brackets. And then I say I want to control the pan widget. And I want to use this mod circuit that I just presented. And now I'm going to connect. So you see here I have the VCO. So I need to put in parallel a LFO. It's called LFO number 3. So now this pan has two inputs. One, the new one is to control the pan position, and the other one was the signal that you wanted to pan. Okay, so let's try this. Is it working? It's so small. Can you hear any left-right panning? No. Okay, it's working, perfect. All these two. Let's see if I move it. Okay, so I need to put more amplitude. Okay. And, but that's strange. Why we can't hear the... And if I move it, because here it's moving. Okay, so let's see at the plot level. well, visually it's working. Okay, I don't really understand why it doesn't work like this. Okay, so let's add some more modulation. For example, I would like to insert a filter after the VCO. So I can just here say, okay, I want to go into a VCF. Yeah, okay. Now maybe 2. Okay, so now if I okay, let's say that I want to modulate the frequency of the filter. I can just do the same thing here. I open the square brackets. And here I said that I want to modify the frec value. I want to use again this, or maybe, no, just an addition. I can put another LFO, but I'm going to pass it as a parameter of the widget modulation expression, just to show you a different way to write things. And here I can write LFO 2. So now if I okay. Okay, so basically this is how it works. Maybe we can try to hear this. More complex situation. Let's see if I'm. Okay, so it's not a real modular synthesizer. It's a synthesizer of modular synthesizer of the poor Faust programmer, but you get the idea that you can easily do this kind of things, and we can imagine to have a real modular synthesizer written for Faust, where you have by dragging the output of some module to a widget, introduce automatically the modulation and do this kind of stuff. And obviously, this example showed the limitation of the current layout, which is a little bit strange. So we have to improve that. And also to provide a library of modules. There are if you go to modular grid, there are tons and tons of different modules. Probably some of them that are interesting to reproduce. And again, this is a new kind of library because you provide a library with the user interface, and you can easily reuse this user interface or really reshape the user interface as you want. So I think that widget modulation is an interesting extension to the Faust language. Voilà, thank you. Are there any questions? Yes.
First comment, this is a great addition. This is a great addition.
Okay.
And secondly, I know the code that Xiong Ren wrote for the graphic interface. It's quite easy to add some way to visually see the knobs and slider move during the modulation at any rate, maybe at the graphic rate at 60 frames per second or 30 or whatever. And this would help understanding who is modulating what.
What I was thinking, Michel, is the fact that we could have a convention that if you have a bar graph with the same name of a widget, then we can imagine to represent the widget with the bar graph around so that you can see the modulation value.
Yeah, we can imagine any sort of feedback, but that would be a great addition. And secondly, is it possible when you add something that modulates another component, another module, that this module exports and describes what can be modulated? I mean, like this, you could imagine writing a generic modulation module that could be plugged anywhere, and you know, building some menus, for example, or some tabs or whatever, without knowing in advance what you want to modulate. I mean, instead of typing the name of the label of the widget you want to modulate, say, give me all the labels, for example.
Yes, but not in Faust. I mean, here we are live coding, so we are writing Faust code.
Yeah.
But you mean in the user interface?
No, I mean here, for example, you typed exactly what you want to modulate. But imagine I want to generate a graphic user interface with all the possible modulations without typing them by hand.
But you have, the point is that as a developer of a module, you don't have to think about what the user wants to modulate, because the user can do whatever he wants. So it would be, I understand what you say, but it could be a little bit in contradiction with this idea. As a user, as a developer, you just develop a nice module with all the knobs, the buttons that you can imagine, with all the selector. And as a developer, you can just remove all of them. And in this case, you don't have any penalty in the execution code. It's like the straight algorithm. There is no penalty starting from a very rich user interface and simplifying it. And as a developer of the module, you don't have to know or think about what the user wants to modulate.
But maybe we're saying there could be, at the graphical user interface level, at least looking at the list of possible names. So we can always, we have this information like in the exported JSON file associated with the DSP. You have the list of all names of parameters. So you could imagine to have your graphical user interface reflect
this is why I asked if it was at the Faust level or the graphical user interface. In the graphical user interface, it makes perfectly sense. Il y a plusieurs questions.
Same, and thank you a lot for this great addition to the Faust language. Just a question on the block diagram. How does it look when you add a modulation on a the simple example?
Let's do a very simple example. Okay, so let's say that okay, I have maybe I'm creating an amplifier. Oops, with here a H slider called gain. Okay, so what's missing here? Yes, okay, it's not there, sorry. Okay, so this is, let's say that I give a name to this, amp equal V group, my amp, okay, and inside I have this definition here. Okay, and here I say I use my amp. Okay, now I want to do the modulation. Okay, so I use the square brackets notation here. I say that I want to modify the gain. And I want to multiply this gain by 2 because the slider is not enough. Okay, so I multiply by 2. So this modulation circuit here multiplied by 2 has just one input and one output. So it's going to be inserted. You see, it's going to be inserted here after the slider. The problem that we have currently that we need to solve, you see that the block diagram are hierarchical in Faust because it keeps tracks of how each part has been evaluated. And it used the evaluation expression, so to speak, the fact that you apply something to something else to create the circuit, as a name to recreate a hierarchy. But here it's lost, so to speak. This is why you have something that is just unreadable. So we have to work on that to improve. Does that answer your question?
Okay, thank you for the demo.
Is going to be always same question for me. Is going to be available from the Box API?
Yes. We need to figure out how to do that. Yes. Currently, I think it's not available, but
not available now.
But yes, we will do that. Yes, we need to Box API to really reflect all the.
Thank you.
No, great question. Yeah. Il y a une question là.
Thank you for really exciting presentation, and it's going to be a big change for in terms of the language design because there in the previous implementation, label had no meaning for the Faust program itself, but it's not no more. It has it does changes if the label name was changed, and I had 2 questions. And
so what you are saying that, okay, let's say that you build something by modulating and the implementation of the widget, the circuit that you modulate, the implementer changed the name.
Yeah,
It's going to break.
Yeah,
Yes.
and that is but another question. I have a question about the grouping of the parameter. So if I want to change modulate the wet parameter, let's say, and I want to control the modulation rate by another slider, for example.
Yes.
And is it possible to group the wet parameter and the newly created modulator rate?
Yes, you can do that. So here, for example, you see that the modulation happens inside the circuit without creating an additional input to the amplifier. But if I wrote things differently, for example, here I say that I want a multiplication here. Okay. Now you see you have two inputs. And if I write here 2 underscore, okay, so we see that the gain is going to be multiplied by 2 here. And I can here put, instead of that, a LFO that will control this gain applied to... does that answer your question? Or
so if I control the rate with the another slider that has another label, so can we group the user interface?
Yes, you can. If at this point you need to insert, for example, let me show you. I have the pan. Okay, so this is the pan. It has the pan value here, and I can say, okay, I want to do widget modulation on this. I want to control the pan, and I want to let's say modulate the pan with an LFO, but I want it to be inside the user interface, so to speak. Okay, so I'm going to write here multiply by LFO 1. Okay, syntax error because I forgot to close this widget modulation. Okay, so now let's run this. And you see that the LFO is inside the now. It's inside.
That's what I intended. Yeah.
That was your question?
Yes.
Okay.
And another question, and I
not too difficult, right?
Not too. Yeah. And I wrote a document on the website, and you can override the modulating parameter with the constant by following the separating. So if I'm understanding is correct, this colon character in widget modulation is semantically completely different from the.
Right.
Yeah,
right.
I felt it is just a bit confusing for.
Yes, I understand. The problem is a little bit a lack of signs to do that.
Yeah.
So the point is that, okay, the colon sign here, it's different from the colon used to compose A and B, the sequential composition. It's different. So yes, I hope it's not too confusing for the users. But, yeah, right.
Thank you.
Okay, thank you. Sì. Okay. Modulation matrix will probably solve the problem of not knowing the possible modulation path in advance. Yes, sure. Again, I was speaking at the Faust level, not at the user interface of a modular synthesizer we could build with this. But yes. Ok, thank you. Posso staccare.
So next speaker is Felix Holzmüller, coming from Austria, Institute of Electronic Music and Acoustic at University of Music and Performing Arts in Graz, and he's going to explain a paper named Assessment of Simulation in Faust and TASCAR for the Development of Audio Algorithm in Acoustic Environments.
So just a quick moment to set everything up. All right, so thanks for having me. I think I've successfully submitted the longest title to the conference. It sounds very complicated, but my problem is actually quite simple. So I'm a researcher on active noise control in time-variant environments. So I'm not working with active noise control on like headphones, as maybe all of you know it, but like in a room situated with loudspeakers that are basically canceling sound at one or more specific positions. And as we can all imagine, in a room, we rarely sit statically at the same position, don't move a millimeter, but we're constantly moving around. The sound is changing constantly. And we basically have to take those time variant changes into account for ANC to work properly. Another problem, another issue, another challenge with ANC is that we have hard real-time constraints. So usually when we talk about processing latency, we want to be well below, at least depends on the application, but well below 3 milliseconds, best would be below 1 millisecond round-trip latency of basically the whole algorithm. So that makes algorithms for ANC quite hard to evaluate and validate. Because basically due to the time environment situation, an offline evaluation and simulation is not always possible. And evaluation on a specific hardware that's optimized for low latency can also be quite challenging. So basically, if you want to evaluate all your algorithms on hardware, you basically have to choose for program all your stuff bare metal for a specific platform. So you're bound to that platform. It's quite time consuming to program stuff applied to a specific hardware. You have to go into low-level C or even assembler to make it work properly. And it's also hard to change some things in an algorithm later on. There are also options around for using a higher level language. For example, if you want to go on an FPGA and don't want to write VHDL code, you can use something like the Cifala toolchain, for example, coming more from the Faust universe, or in ANC, some commercial products like DSP are quite commonly known. But those have quite a high entry level in terms of making the toolchain work and also in terms of cost, because you need some dedicated hardware to run it. So you have to have the hardware in-house. You have to buy the hardware in the first place. Then also with running such stuff in the real acoustic space, you have a limited repeatability, like in 3 days, your temperature changes slightly in the room and you can't repeat the measurement and get the exact same results as before. And you also need some kind of dedicated measurement space to measure stuff. So I'm using for my work often real-time simulations of acoustic scenarios. So I came across TASCAR, that's the short version for Toolbox for acoustic scene creation and rendering. That's basically an open source audio virtualization tool. It's made by Guido from the University of Oldenburg in Germany. And it basically has widespread use in the hearing aid research in audiology. I came across it actually from the deep learning lane because it's sometimes used for generating artificial data. And it features basically offline rendering of acoustic scenarios and real-time rendering with basically a sample accurate auralization. It's built upon the Jack Audio connection kit, so it uses all the I/O from Jack Audio and also the time lane. And basically the user can interact directly via OSC to change positions, to change parameters in real time. So what you see here on the right side is basically just a visualization part behind it. And basically all scenes are predefined in a kind of XML-like file. And that's just a bit of visualization for what you're doing in there. So I found TASCAR, and after a bit of looking, also found Faust to combine it to. But before I'm using it from research, I wanted to basically test it, how well it reproduces results that are maybe comparable to physical measurements. So I tried to compare it with 2 different approaches, like how accurately the sound field is recreated in the simulation compared to actual measurements. And also if I'm programming, if I'm applying some kind of algorithm, acoustic algorithm, in my case an ANC algorithm, basically if the algorithm behaves kind of similarly. So to do that, I've tested this with 2 different rooms we have at our lab, some kind of anechoic, semi-anechoic measurement room, and a kind of reverberant, very anisotropic meeting room with different source configurations. So I basically set up some kind of linear microphone array. You can see this here in our measurement space. Basically placing 25 measurement microphones on a straight line to capture basically at least one dimension of the sound field. With different source configurations around it, so a ring of loudspeakers, and also for ANC, I've put there one loudspeaker to measure some impulse responses. So that loudspeaker is used later on in the simulation to basically cancel the sound. So we placed this here just for measuring the IR, and then removed it from the room again. That's the second room, so that's our meeting room. Actually, right here is my desk normally. So we have kind of windows, we have drywall, we have an acoustic ceiling, a hard floor. Here on this side, we also have glass windows or glass walls. So it's kind of a difficult acoustic scenario, but I wanted to try both extremes, like a very dry measurement room and a very reverberant, anisotropic room. So from a research project, we had 3D scans for the whole room, where I took the coordinates to create the TASCAR configurations. I estimated from a database basically some absorption coefficients to bake them into the acoustic simulation. And I wanted to evaluate also basically what degree of detail I had to use for my work to make it work. So I've tested free field conditions like no reflections at all, then just a simple image source model, then in the next scenario also with some kind of modeled directivity of all the sources I'm using. So basically loudspeakers are, of course, getting some kind of having a narrower directivity towards higher frequencies usually. So that's baked in. And in the last case, also with diffuse FDN reverberation. For all the room acoustic sound field analysis, I rendered them offline. So I had I used our deep learning node for half an hour to render all of my stuff. And the real-time processing actually happened online on my not this notebook, but on my Linux notebook at work. So to analyze the sound field, I basically investigated two different properties. So basically how the sound level behaves on this linear microphone array compared to the measurement at like similar positions. And also how the spatial coherence or the spatial correlation look like. So as it's not that common as a measure, basically the spatial correlation has been widely used since the 1950s to describe different sound fields. It's well defined for like diffuse sound field, how the spatial correlation looks like. So we are basically calculating the correlation coefficient between a reference position and different positions. So in my case, I'm comparing it to the center position and to all other positions along the array. So measuring the correlation can be kind of a tricky thing because it's only valid for this one test signal you're sending into. So it's only valid for this specific frequency or for this signal. So I'm using the spatial coherence that's quite related to the correlation. It's just, you can think of it as the spatial correlation just in frequency domain. So I'm using a broadband signal and I'm picking out one frequency bin, so to say, to just look at the behavior at this specific frequency. So let's take a look at the results for the sound field in the measurement room. So for just one source in the front active, we see quite a good match. So in blue, I hope you see it on the projector, is the measured curve, and basically with different colors are different degrees of detail. So we're actually quite good to use actually just in this dry measurement room, just a free field simulation or just some image source model. It's not that hard. Looks quite different in the more complex acoustic scenario and the more reverberant scenario. So now the image source model clearly improves the plausibility of the level distribution. Actually, when I'm including the directivity of the loudspeaker, we actually see worse results. I think because maybe the directivity is too narrow for some of those frequencies that I'm analyzing as well. So good news, just a simple image source model works quite well in my case. Looking at spatial coherence, we also see, the measurement matches our simulation quite good, especially near the source. The further we get away, the more differences we see, but it's kind of okay. Also for a different source configuration. In the more demanding room, things don't look that good anymore. So we see quite big differences to the measurements for one source and for all four active sources. There's not that much similarity if you move a bit away from the reference position. So the sound field differs quite much, actually. So to the next part that's actually more interesting on a Faust conference, I'm hooking up TASCAR for the acoustic simulation with Faust doing all the signal processing, all my algorithms behind it. So I'm basically using some kind of ANC algorithms. So basically we have some disturbances to the plate by one source. We have a secondary loudspeaker that are playing basically the anti-noise, so the noise that should be canceling the sound out at the reference position that we're looking at. And those ANC filters usually work by means of an adaptive filter. So we have some kind of signal that we filter to be played by the secondary loudspeakers. And this filter is adapted online using the error signal at the position where we want to cancel sound. So we actually have some kind of recursive system. So we basically use the output, the signal at the listening position coming from the simulation, and also playing some sound into the simulation again. The acoustic simulation is done in TASCAR, as said before. For the signal processing, I'm using Faust. So I'm writing all my adaptive filters in Faust and compile them to a Jack standalone application. Meaning in this case, my total system latency is just defined by the settings I'm setting for my sound card. And I'm comparing basically the full scale simulation to measurement-based co-simulations. As we don't have the hardware in-house to compare it in the real acoustic space, I'm just using the measured impulse responses to in a Python simulation. So that's working on the real impulse responses, but it's still simulated offline. If we have a look at the adaptation of the filter, we see, again, in the purple curve, it's dropping to kind of infinity. So that's the case where we don't have any reflections pulled into it. So that's not very realistic in my case. But at least if we take some reflections into account, we get results that are kind of in a similar range. At least in the very dry acoustic scenario. In the reverberant scenario, approach basically isn't working at all because I'm too limited with the filter lengths with Faust and TASCAR to use here to make it work in a reasonable amount of time. Second thing we could look at is the steady state spectrum. So basically the spectrum of the sound after the filter has adapted. Although we see some differences, so with the measurement, it's kind of a white steady state noise. In the simulation, it's a bit tilted, but it's also kind of in a similar range. So I'm anticipating that it's also caused by frequency responses of the loudspeaker, and I'm not taking into account in the simulation. So to quickly conclude, I'm using successfully Faust and TASCAR in combination to evaluate all audio algorithms in an acoustic space. So this enables me for getting good, kind of comparable results, at least in low reflective environments in a relatively dry environment. In diffuse settings, it's maybe not the best approach. It's maybe not the most ideal thing to do. But still, it's quite a handy tool for quick experiments and pre-studies, but it can't place real physical measurements completely. So I'm working also, or not working, I've successfully done it to hook it up to external sensors to enable me to do real-time simulations. That's actually a quite neat use case to do. And at least in my kind of work, and maybe if I have some free time at hand, I'm thinking about just building for myself like a Faust 2 TASCAR tool, because TASCAR basically supports modules for doing some signal processing stuff internally. So those modules have to be written in C. I try to avoid using lower level languages. So it would be quite an interesting tool for my work at least. So that's it mostly for now for me. I can just quickly show you how my kind of tool chain would look like in this type of thing. So I'm basically have a small script that are measuring on some kind of configuration file, measuring all kinds of impulse responses in TASCAR offline that I'm needing for my algorithm. And that's basically calculating all those filters that I'm needing for running all the signal processing behind it. So basically the output of this measurement script would look like this. It's just a gigantic read table with all those filter coefficients I'm using. And that's basically imported into my Faust script used for all the filtering I'm using. And basically, everything is compiled and baked into my Faust applications. I can simply run my demo, and I don't have sound, it's just white noise, so I don't want to disturb you with just some white noise. But I can hook up some tracking devices to it, and just, okay, thank you. So I just have to set up a jack to work. I think it should run. So I'm just starting a small Python script that is basically starting up Faust, is starting up TASCAR, it's starting up a quick UI for my audio, for my head tracker. And it's not much to see, but I'm just hooking it up to TASCAR, so you can see the position that is moved basically. And you also can see that I'm getting the position in all my Faust applications. And it's quite a handy tool to evaluate how all this algorithm works on a perceptual basis. So I'm just listening into it. I can see, okay, and there appear some artifacts if I have movement. Those artifacts aren't necessarily on measurement data, but they can be perceived. Okay, I have to look at it and optimize it further. And yeah, that's basically my use case of TASCAR at the moment. So yeah, thank you for your patience with me with this quite different topic in TASCAR. And yeah, maybe if there are some questions, I'm happy to answer them. Everyone wants coffee.
Yeah, really nice workflow. So you did you? Sorry, better. Did you code yourself the FXLMS in Faust?
Yes.
Okay, yeah. And so the interaction is made through Jack. That's the idea between the different softwares.
Yeah, exactly. So TASCAR only works with Jack IO. So I'm building also my control filter for ANC with project support.
Okay.
Basically.
And do you plan to do an online experiment like a Cifala or I don't know another controller at some point?
Not at the moment, to be honest.
Okay. Okay. That would be a nice project. We might exchange a bit more at the coffee break, I guess. Thank you.
Thanks.
Thanks for a great talk. I think Faust TASCAR is a really good idea, and there's a lot of there's ever more materials out there on writing Faust architectures. A lot of examples, so I think it's a really good idea. I have one kind of possibly daft question. Can you tell us about your headphones? Have you modified those? Does they have an accelerometer in or something of that nature?
No, I'm actually using the Supperware head trigger.
Right.
So Ben Supperware sells them basically, so they are just small strips you can place into your headphones. So they are quite nice, quite fancy. You get basically position data as a MIDI stream. You have to decode them yourself if you use them like in the application, because you just get MIDI on a bit stream level. But they also have quite a nice more user-friendly application with OSC support.
Yeah, and it's very unobtrusive. That's a really interesting bit of tech I wasn't aware of actually, but it makes sense that it exists. Cool, thank you very much.
Coffee break, maybe.
Okay. Welcome, everybody. I am Domenico Cipriani, and today I'm presenting Fausto, Fast and Accessible DSP Programming with Faro. And I want to thank the IFC 24 organizer for putting up the conference and for hosting me and let me talk about Fausto. Then I want to thank a lot the Faro Association for sponsoring me and so giving me more time to work with Fausto and with music with Faro. This is a nice thing of the Faro Association. We are doing the Fausto Association, so the Faro Association is helping individuals. So they have the Faro Association and the Faro Consortium. Faro Consortium is for companies, and Faro Association is for individuals, basically. Yes, and then I want a special thanks to Stefan Slets for helping me with the dynamic library and with my questions, sometimes very newbie, about C++ compilation and stuff like that. Okay, so what is Fausto? Fausto is a multi-platform library and API with which we can write DSP in Faro. The audio is generated through a foreign function interface called to a dynamic engine that computes the audio signal with the power of an embedded Faust compiler. So thanks to the possibility of embedding the Faust compiler almost everywhere, we can embed it also with in Faro. And then we can use all the power and all the libraries or Faust that are very good and sounds really good to me. This is very important. And about Fausto, so Fausto was with three main goals. This was to allow sound artists and musicians to program their and compose their music with Faro, so as an own contained system. Like yesterday, I was doing the performance all with Faro. This is one aim. The other aim is an educational goal, so is to teach DSP programming to beginners and sound artists, because in my experience, I'm doing workshop about producing music, mixing, mastering, using hardware and synthesizer, and also using programming language. And my experience was when I tried to do a little Faust workshop that for beginner, it was a little bit intimidating. So in terms of educational, I will talk a little bit, then we start with the workshop. But I want to say, Fausto is not intended to substitute Faust. It's not a competitor of Faust. Of course, then without Faust, there is no Fausto. So, but the thing is, maybe I think a lot of producers, sound artists, maybe they can start with Fausto, and then they can say, okay, programming is not so hard, and then when they can do simpler stuff with Fausto, and then when they decide, okay, now I want to do something like the ABC library or these granulators and these spatial things, then you say, okay, now it's time to learn Faust. So it's a bridge, it's like a door entry to also to Faust and to the programming world in general. And then the third goal was to have sound in Faro, because Faro didn't have sound. We will say, how many of you know Faro? 1, 2. Okay, so we have to talk a little bit about Faro. Faro is a pure object-oriented, dynamically typed, reflective language. Its syntax is very minimal and fits in a postcard, and it has a platform-independent IDE. It's a language with a virtual machine, so it runs in every system, okay? It's cross-platform, and it's an implementation of the classical Smalltalk 80. How many of you know Smalltalk? A little bit more. A little.
E come facciamo?
Okay, so Smalltalk was created at the Xerox PARC by Alan Kay, Adele Goldberg, and Dan Ingalls back in 1972. It was designed as a purely object-oriented language, also with a IDE and the system where everything you do inside the system, okay? And it was intended to teach programming for young people at the beginning, especially for constructive learning. That was the aim at the beginning. Then a company bought the Smalltalk system. It was closed system. It was, I think, the main company was called Syncom. They made their business model. It was quite popular in the 80s, especially in the US, but also in Europe. It was very expensive and closed. So then, at the end of the 90s, the same group of the original creator, they decide to do a open source implementation that is called Squeak. And Faro is a fork of Squeak that came, I think, in 2011. So it's a little bit younger than Faust. No? Okay. One question can be just really quick. Why do you know Smalltalk? Why do you know Faro? Why are you using this thing to do audio and sound design if nobody is doing sound design with Smalltalk or Faro, they say? Because I was using symbolic sound schema. How many of you know symbolic sound schema? 1, 2, 3. Okay. It's a music programming language with an IDE. So in the spirit of Smalltalk, with all the things, you know, you can see it's graphical, is a mix of graphical and textual, okay, language created by Carla Scaletti and Kurt Ebel at the University of Urbana-Champaign. It is called the holy grail of sound design, okay, because it sounds really good and it's very powerful, but it needs an external DSP. The first generation was called Capybara, then there was the Paca Rana, and then now they have the Paca Mara Ristretto. And the problem of Kima is very good, but it has two problems. The first problem is that it's closed source, not free, and very close everything. And then the DSP, the last generation, cost around $4,000. So it's kind of intimidating a lot, especially for educational purposes. Okay, there are this tool to learn Faro. Now in this workshop, I will introduce you to Faust. I will introduce you a little bit to Faro. Of course, we cannot explain Faro in 1 hour, but there is a MOOC, both for beginner and then for advanced object-oriented design. How many of you are familiar with object-oriented languages? Okay. Good. So we first have to install Fausto, and to install Fausto, we have to go to faro.org/download. That is this page here. The immersive programming experience. And if you go to download, then you will download the Faro launcher. What is the Faro launcher? The Faro launcher is an application written in Faro that launches Smalltalk, a Faro image, okay? Because Smalltalk is running on an image. An image is like all the application with all the classes you created is like a persistent object of the state of your program. So now we will see when you install Faro that Faro, the good thing about Faro is that you have the IDE and the class browser and the tools for continuous integration all in the same application, okay, in the same programming. So you don't have to write with Visual Studio Code or whatever you're using. Okay, so you select the architecture. I will wait for a while. The Faro launcher. Looks like this. Okay. I wait a little bit. Okay. If you have any question, issues, complaints, whatever, ideas. Now we have so few things. Okay, once you have downloaded the Faro launcher and you you open the Faro launcher and you have to go to New because you want to download an image. And from the official distribution, you can download the Faro 12, that is 64-bit stable. And you click on Create Image. Can we go on? So once you have your image, you double click on the image and it opens the Faro world. Okay, this is called the Faro world. Okay. So in the Faro world, we have many tools. We will try to look at least a couple of them. But the most important tool for us to use Fausto is the thing called the playground that we can open with command and O and W, or also from the menu here. It is on playground. Here you have system browser, Git repository browser, playground. Okay. So the playground is where you can, let's say, write script of Faro language. It's like an entry point to develop your Faro application, because then we will see there is a more complex system or organizing code. But here, for example, if you type 3 plus 5 and we press print, command P, 8. Oh, wow. Or we can ask for 25 factorial. Or we can also, let's create an array. So array 1, 5, 7, 99. And let's inspect it, command plus E. And we can inspect and we can see the value at each position of the array. So we'll see now a little bit of Faro syntax. It's really, I think it's really easy to learn. If you think that is not, please tell me. I will be happy to listen while. One thing that is different from the other programming language that you are using is that arrays and collection in general, they start counting at 1. So there's no array at 0. It will say, probably I will say array at 0. And it opens a debugger. And you say subscript out of bounds. There is no 0. So every time an exception is raised, it opens the debugger, and then we can go down the execution stack, and we can see where was the problem. And then there is this thing called test-driven development, or extreme test-driven development, where you can write the code inside the debugger. This is a very rich feature of Faro, maybe a little bit advanced for now. Yeah, so let's go back to the presentation. If you have installed Faro, then you have to go to the repository that is this github.com Lucretio MSP Fausto. And once you go there, there is a little bit of help, but there is also a wiki page that guide you to the installation, okay? So basically, you have to download the library for your platform, Mac, Linux, Windows. Here, you find it. And then it explains that you have to copy next to your image folder that is in the documents, okay? There is a folder that is Faro, and then there is images. You have all your images, probably just one that you just download, and you go to the image folder and you place this libraries bundle. What do we have in the libraries bundle? We have the dynamic engine that is compiled with libfaust, and we have a folder with the Faust libraries. Okay. Once we have copied the libraries next to the Faro image, we have to download Fausto, and we do it copying and pasting in the into the playground these two Metacello script that takes care of downloading all the dependencies. So you have two options. You have the option with just Fausto, or you have the option with the user interface that is called Koipu IDE. I recommend you to use the one with the interface. The interface is made with Block, that is a UI framework, low-level framework in Faro. So I already did it, but if you didn't, you just copy the script into the playground, and then you press Command D. With Command D, we evaluate the code in Faro. So, for example, if I want to see a transcript is basically a console. I do transcript open, and I execute the message with Command D, and say some bullshit, because it's like that. A few words about, before going to Fausto, a few words about the syntax of Faro. All Faro syntax can fit on a postcard, and basically there are 6 basic rules. Everything is an object. Every class has a superclass. Everything happens by sending messages. Method lookup follows inheritance chain. So when we define a method, then if the method is not present in the subclass, it goes up, up, up until the object class, because all Faro object inherits from object. There is this at the top of the inheritance chain, there is the object. The reality is there is also a proto-object, but let's say that it is just the object. And then classes are object too, okay? So everything is an object. About the messages, there is the execution of the messages, like the priority. Unary, this is an unary message. So unary messages are executed first, then the binary message from left to right. This is strange. This is one of the stranger things of Faro if you come from another programming language. So if you ask for 3 plus 5 times 8, what is the result? Is 64, okay? Because it's first evaluating the left and then the right. It's not like the precedence is not the precedence, normal precedence of the mathematical operations. This is a kind of thing that we have to take care of, but of course we can just put our parentheses, put our parentheses. Okay. And we do our precedence rule, okay? Once we have Fausto installed, we can try if it works. There is a assistant with, now there are only 7 lessons, but I'm working for more lessons. The assistant is called Master Lou. I don't know if the name maybe should be changed. But if you send a message, go to Master Lou, okay? It opens another playground where you have the first example code of Fausto. Okay, so there are the few rules. Let's see if it works here first. So this syntax is how we declare variables in Faro. Okay, is column and equals. Okay, is strange. If we are not in a playground, we should have first to put the variable in between pipes. But writing code into the playground, we don't care about this because the playground is like taking care of making this thing for us and put this thing in the bindings of the playground, so on the variable of the current playground. Okay. So the first thing, we create a variable and we ask for a sine oscillator. The sine oscillator is a sine oscillator from the Faust standard library, okay? So let's see if it works and then I will explain about it. First, we create this sine oscillator. Then we send the message as DSP to this sine oscillator, okay? And now, once we have this, we have the DSP object running behind. We have the structure that we have to initialize with the dynamic engine, so connect to our audio layer, that is in this case is port audio. A little thing sometimes is crashing on Mac because of port audio, not because of Faro, not because of Fausto. It's because of port audio. I will recompile the library to use core audio next week. So this was an issue of port audio. Then we initialize the sound. Then we start the volume, non so quanto. Lo ce l'ho al minimo io, aspetta. Vabbè, lasciamo al minimo. Oh, wow. Okay. Easy like that. So, very easy. And one thing, when I was designing Fausto, I was thinking a few things to make it simpler. So, for example, all the unit generator, I call this generator of the function of the standard library of Faust, I call it the unit generator, okay? All this unit generator comes with default parameters, okay? I try to make something reasonable, something sensible, and also all the parameters that does not have to define that compile time, they come with a UI, okay? With a UI parameter that you can access, I will see in the next lesson. So you don't have to worry to build the interface. You can, we will see later, say, I don't want the interface, but it comes by default because I thought that was simpler for people that has, this was like, one thing I found, for example, in Faust is if you have something easy, you have to write a lot of code for the UI, and that maybe this for a beginner is not something so nice. So we can stop the DSP, and if we want, we destroy the DSP, so we clear the pointer, and then we don't have issues with that. The DSP as DSP method is taking care of destroying the pointer, but sometimes it's tricky. So if you want to destroy it, if you want to take care of that, then we send the next message to Master Lou, and we have the second lesson. Okay, a sawtooth. Okay, so oscillator new. Another thing, I try to stay as possible as adherent to the naming of Faust, both of the unit generator and both of the parameters. So once you say, okay, I'm tired of Fausto, I go to Faust. Okay, you know how to call them, and you know that is a frequency parameter, that is gate, that is trigger, so you don't have to rethink about and something confusing, okay? Then I implemented the stereo message. The stereo message is taking the signal and splitting into stereo. Very easy. Again, I think it was a simplification that was useful for the people. So let's say, good. Maybe boring. We destroy. Okay, next example. We create a pulse oscillator new. We convert it to DSP. We initialize it. It's starting. Okay. And now we can set the parameters from the code. So we have this message that is set value parameter. Okay. And you have to put the name of the parameter. And you will say, how do I know the parameters of my DSP? You have this message, DSP, trace all params. We evaluate, and it say to me, pulse oscillate, pulse osc duty, pulse osc frac, pulse osc U level. I introduced these level things for all the unit generator. I decided like, okay, it will be cool to have a volume control. Also for whatever you have this U level that is not in Faust, but is to access quickly the volume, otherwise it explodes and you don't know how to load again, okay? Again, once, every time you create a pulse oscillator, Fausto is giving it a name. The name is class name, so pulse osc. If we create another pulse osc, there will be pulse osc 2, and then pulse osc 3, and pulse osc 4, and so on. So we don't have also to worry about naming if we don't want, or we can, and we can just change the label. Okay, so everything, every change in parameters we say, all the unit generators come with Faust parameter, UI parameter. So we can manipulate the values at real time. And all the work of setting the values of the parameter is with this keyword message. This is it's called keyword message in Faro that has two arguments. One is the value, and the other is the name of the parameter. We can stop the DSP, we can destroy. DSP, destroy. Okay, we go to the next. We have also like, now the status of Fausto is we have like around 40% of the Faust library. I will have to, in a couple of months, I think 100% of that will be available, including all the physical models, all you need to construct instruments. At the moment, we have, for example, the djembe. Okay, so we just say djembe new, and it's taking care of creating all the parameters, strike position and strike sharpness for us. So if we want just a standard djembe, then we convert it in a DSP, we initialize. Okay, of course the djembe need a trigger to play. I could send a message set value 1 to the trig, okay? Or if I downloaded the Fausto version with the block UI, I just send a message display UI, and we have this nice UI made with block. And at the moment it's just sliders and buttons. But in the next month there will be like radio buttons. You will have the possibility to decide if you want a fader, horizontal or vertical. Now it's like everything is like that. Also you. Nice. We can go to the next lesson. Okay. Now, for example, this is the noise, just to see another thing. Noise status, DSP. We start. Okay, kind of boring. But then in Fausto, we introduced this chuck operator. How many of you know the chuck programming language? Yeah. So we friendly borrowed the chuck operator, okay, that is like magic operator that is taking care of connecting the unit generator. So it's an arbitrary choice. Of course, you can connect it like in a low level way. But if you send, for example, if you the chuck operator message depends on the argument, okay? So you say, okay, you are chucking something into the gray hole river. It means that you want to connect this to the input, right? If you don't want that, you have to specify that. Okay. Of course, in Faust there are all the basic operator of Faust. So split to, merge. I changed the column to a keyword message, so is connect to. Okay, because I think it was a little bit clarifying, also because the comma is used for other things in Faro, so it was a little bit confusing. Then you have mathematical operators, times, division, absolute, smoothing parameter. Okay, some things like multiplication or smooth. Okay, I decided that it was easier to implement it like a method, so you don't have to draw to design the circuit with the smooth, but you have just to send smooth to the parameter, and it's taking care of behind the scene, is taking care to build the box and to do all the connection to the to do your circuit. Okay, so now we can do this electric guitar, send it to the gray hole river, synth as DSP, init, start, display UI. Okay, so it's easy like that. Now, let's go a little bit deeper into that, and then we will make more things out of the master loop. This is the last lesson. Okay, so when we have this this message, this keyword message are setter. Okay, are the message with which we set the parameter of a unit generator. We can go. Okay, Faro is completely reflective and introspective language, so we can inspect everything. And for example, we can go just with the name of electric guitar and press Command B, and it opens the class browser for us. Okay, we can see here there is the Fausto package. The package is a collection of classes. We can create our own Fausto or our own collection of unit generators, and then it's organized with tags. So for example, the electric guitar is inside the physical model, inside the string instruments. Okay, and I see that I have plug position, gain, trigger, mute, and then if I go up to is a superclass, the string instrument also has a freq. Okay, so these are accessor methods, but we can set the freq by ourselves. So what happens? This setter method depends on, again, on its argument. So if we are, if the argument is a symbol, this with the hash is called symbol in Faro, and is a unique string. Okay, just a string, unique. If we send a message that is if the argument is a symbol, it say, okay, I change the label of the UI parameter. So if you have many things with the same name, or if you want to make something different, you can just change the name of the label. Or, for example, you can send an array where we put like the initial value, the minimum value, the maximum value, and the step value. So if the argument is an array, say, okay, you want to change the init, min, max, and step. If the array has five, elements, so like guitar note, this is a Faro string between single quotes. You say, okay, the argument is a 5 elements array. It means that you want to change the label and you want to change init, min, max, step. Okay, let's go back to what we have. But what if we want to have another like unit generator? We can specify like LFO, triangular positive, new, and you will say, okay, so the argument is a unit generator. You want me to replace the UI parameter with a unit generator. So the UI parameter will disappear, and you will have your unit generator doing its stuff. Okay. And if you just send a number, okay, you say, okay, you just want to change the initial value of the UI parameter. You are good with the label, you are good with the min, max step value, but you just want to change the initial value. Okay, let's go. But let's go back to what we have before. Okay. So here we are creating a electric guitar new, and we are changing the name of the label to electric guitar note, electric guitar gate. We create the DSP. We initialize with start. Why did we change the name to that? We changed the name to that because there is a method called play note that actually is playing a note, so it's converting the first argument of play note is a number for a MIDI note, so 60, 48, whatever, and it's converting it to a MIDI to a frequency, okay, with the behind the scene the MIDI to FRAC function of the Faust library. Then it needs a prefix. You say, okay, electric guitar. Okay, so if you say that you want to play the electric guitar, it means that you are electric guitar as a note parameter and a gate parameter. Otherwise, it will raise an exception. And then you have a duration, okay? So we create this pattern. This pattern, what it is? This is called a Faro block, okay? And this Faro block is like an anonymous function, okay? The function is there, it's not executed. And what it's doing is playing a random note between 28 and 76 with a duration of 11 milliseconds. And it has this delay that you say, every time I ask for a new random number, I wait 125 milliseconds, okay? So we have our block, and then we have to start our block. We say, we create a Faro process. We say we want 128 times repeat this block. And fork is the message you send to a Faro block, to a Faro process to start the process. And yeah. Yeah, there was a little bit of something. Yes, so the thing is that basically you can create, so with Fausto you can create your own DSP, you can display UI, you can play it, so you can design them, okay? And then you can play them from Faro. If you do this kind of, if you create your own Faro processes and block, it's a little bit tricky, algorithmically composition. It's all like vanilla Faro. You don't need another package. But for example, yesterday I was using this other package that is called Koipu, that is a library for Faro that is made for doing live coding. So I was sending, like, we will see probably a little bit later, down beats, up beats, and playing also with that. So the idea of Fausto was also to create to be able to do live coding music with Faro and not to depend on another programming language and another code editor and so on. Okay. Now we try to do more stuff. Was it clear until now? Do you have any questions? Okay, we go on.
So, for example, we can create a, let's call it synth, but it's kind of stupid. And we can have sine, os, new, and we send frac. And for the frequency parameter, we say we want an LFO. Which LFO? We want an LFO triangular positive, new. Okay, with the new method, we create new instance of the object. Okay, so we are creating this synth. Then we create the DSP. So DSP is synth as DSP. And then we initialize the DSP. And then we start the DSP. And then if we want to see the UI, display UI. Okay. So far, so good. So basically, all you need to do is create new unit generators and combine the new unit generators. Then you can decide to change the UI parameter. There is another thing that we can do. So we create, let's destroy this. Imagine that we want a MIDI. Okay, in Faust, you know, we can create MIDI DSP. Okay, do you know how to create MIDI DSP in Faust? You have to have you need free UI parameter that has the name frac, gate, and gain. These converted in a MIDI DSP that then, of course, you have to somehow to connect to your MIDI controller devices and MIDI architecture. But at the moment, let's see what it happens in Faust. So let's say that I want an envelope, okay? And the envelope is a DSR envelope, new. I want to change its UI parameter name for the trigger. I want to be gate. So I just send a message trigger with the argument this symbol gate. Cool. Now I want this sign. Let's change it for a square. Square os new. And I want that this frequency is with the frac label. And also with the semicolon is the Faro operator for cascading message. So we can send more messages to the same object. And I want to say that this U level is called gain. Okay? And this is my oscillator. And I chuck it to the envelope. Okay, so first I evaluate the envelope, then I evaluate the synth, then I make the DSP, then I initialize, I start it, I display the UI. Okay, now it's a little bit too small, the screen, but you see there is a keyboard. So when you create a DSP, a MIDI DSP Faust program, the UI show you a keyboard that you can play with the MIDI, with the computer keyboard. That's cool. Okay. What can we do now? We can stop the DSP. Imagine that now we say, okay, we have created this amazing synth and or effect. If it is an effect, we don't have to worry to change the name of the labels or just at our choice. So once we have this DSP, we can create a C major MIDI patch name Torino synth. The argument is a string. Okay? Well, is crashing. Very good. Let's go back. No, was not this the image. Okay, we can open a playground. The playground should remember this. So let's do it again. Tac, tac, tac. Wow. Okay. Why this is so I can inspect a label. What is this doing? Ah, okay. So let's copy the code and I go to an other image, my old image that I used yesterday. Let's see if it goes in the other image and then I explain you the problem. Okay, okay. This is just the same. We can change the appearance, make it darker, so it's cooler. We put the same code, we evaluate the same code, ta, 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 ta. Okay, it's working, let's see. Okay, now it's working. Why it was crashing? It was crashing because here in the wiki page of Fausto, it tells you if you want to export to a different architecture, C++, C major, Bella, Julia, whatever, you need to download this architecture folder, okay, and to put it, okay, now I fix it, but you have to download the architecture folder and put it next to your Faro image, okay, the architecture folder is here, okay. At the moment, I'm using the C major and the Bella, but then I will put all the architecture that are available from the fantastic Faust compiler. Yeah, so once you have created this C major patch, how many of you are familiar with C major? Yeah, C major is a new language that allows to, is imperative language, procedural C-like, that allows to create your plugin or audio application. And what is cool about C major? The cool thing about C major is that they made a plugin wrapper and you can use just the C major file to create the plugin, and we see. So once we export the patch, Fausto create a folder in your documents folder called C major patches. And then when you export a particular DSP, create a folder with the name of your of the string, it was an argument, and with 3 files. One file is the C major code, one is the C major patch, and the other is a polywrapper C major file that was made thanks to Cesar Ferrari of C major to have polyphonic synths exported with Faro, because I cannot access the Faust 2 tools from Faro. I can just access the Faust compiler command line option. So that we had to rewrite the C major patch and this C major polywrapper from Faro manipulating string. So now if we open, for example, let's do the Ableton Live. Everybody hates Ableton Live, me too, but let's do it with that. Easier. So a few words about C major. Yeah, the C major. You can go to the GitHub page, releases page, and you can download. There is a binary file. There is a DMG, and it contains the C major plugin, VST free, that you have then to manually put into your plugin folder. If you are on Mac, is library, audio plugins. Okay. And once you did that, you can go here. Let's make it a little bit smaller. So in my plugin section, I have C major, software limited, and I have the C major plugin. And I put it on a MIDI track of Ableton, of your digital audio workstation of choice, of course. And there is this drag and drop C major patch file. Probably Cesar told me that they are working on something more beautiful and pretty with a kind of menu with selecting, just going to your C major plugin folder and display, showing all the plugins that you have. But for now, it's very simple like that. So you can go to your Finder, and you have to go to the document folder. You have Torino synth. A little bit tricky. You take your C major patch. It gives you an error. Yes. The error is that at the moment, the C major plugin that you are making has to be stereo. Stereo. If you make a mono plugin, you say, what? You told me that in the C major patch file and in the poly wrapper, you say that I must be stereo. What the fuck is happening? So let's delete this one. Move to bin. Let's go back to Faro. And we do this, and we put the magical word stereo. We initialize. Okay, crash. Thanks, Port Audio, for the love. This is Port Audio. Just a second. That will not happening next week, so at least for macOS. We go back to the Faro launcher. We go back to my image. We open the playground. The playground is this beautiful thing where you can load your previous code, even if it's crashed. So let's go there. Tac, tac, tac. Start. Create a C major patch. Okay. Back to Ableton. Yes, it's auto reloading, and it's giving auto reloading. It's giving you this UI. It's okay. You don't have to worry about the UI. You can specify with C major. You can specify an UI with JavaScript and web components, HTML. In the future, one of the ideas we have is to write the UI in Fausto, Faro, block, and then have some kind of exporter to have something at least prettier. But you know, if you want your effects or plugin, you have it, and then you create your MIDI clip here. Yeah, it has to be wrong place for the plugin. It has to be in a MIDI because it's a MIDI. Yeah. So. Torino synth. Torino C major patch. Drawing. Let's see. C'è qualche audio che viene fuori? Sì? No? Forse si apre, vediamo. Forse se l'ha mangiata. Ah, ok. And it's poly. Okay, so it's easy, you know, and the idea is that sound artist, producer, they can make, I want to simply two operators and FM synth. Why don't doing that? Yeah, I can do it. Or I want a reverb. Maybe I want the gray all reverb, but I want a filter on the left and another filter on the right. Let's do it. You can use it. If you use it for you, cool. If you want to make it in a commercial plugin, this is out of my scope. You have to talk with other people. But then, yes, another couple of things. If we go to the class browser, the idea is to have all the libraries of Faust, and then to have two things called Toolkit and Turbo Fausto. The toolkit will be kind of a thing like an helper, okay? So where you have, like, for example, you have a sample player that is based on the sound file primitive, but is made easy to load just a string with the name of your folder, not too much hassle. So the toolkit is a kind of simplification over Faust libraries. And the Turbo Fausto is a collection of synthesizer and effects that is intended to be used with live coding situations. So with Koipu, the other package. Yesterday I was using like Chordi, the free voices subtractive synth, FM2op, as the name say, two operator FM. There is a clone of the 303, and there is a couple of effects. Like I just put a dry wet mechanism into the gray also. I can use it with dry wet, and I put a delay mono feedback that is just the smooth delay of Faust, again with feedback and dry wet control. So for now, I think is everything. If you have any question, you're welcome now or later or whenever. Drop me a mail or drop an issue. If it's not working on your system, we will be happy to help you. Thank you very much.
Hi. Thank you. I think it's quite impressive already. I have a question about how do you export C major code? Are you using libFaust for that, or you are calling an external Faust to C major tool?
No, I show you. So we can go. Okay, so in Faro, the cool thing about Faro is when you start learning Faro, there is this MOOC, okay, and you start learning Faro. The MOOC is like 7 weeks, but if you are very avid and you have not so many friends and don't have a social life, maybe you can do it in 3 weeks. But the cool thing of Faro is when you learn a bit that you can inspect everything. So I can go, how this guy made this thing, Command M, and I see how this method was implemented. So basically, he's creating the folder with the name that I go, then he's trimming, make a little bit of magic, trimming the C major poly file, poly wrapper, you know, he's creating a C major poly wrapper and a C major patch file name. Let's go to the C major patch file name. The C major patch file name is all Faro and is like string, just a string opening the file. But what we want to see is the C major actual file. So to see that, we go to create. The method is libFaust unique instance. So is the FFI call to the library libFaust, and is create C major MIDI file from string. Okay, let's inspect that. Again, this is a little bit recursive FFI mechanism in Faro, and I go inside, and this, maybe I can see the method, there are many, but here we see the final thing is I'm creating the array of strings for the, so you have the arguments, you looking for the architecture in the patch near to your image, you ask for the language is C major poly, and we have the file output. I put like a standard, like 16 voices polyphony, and you can go more than that.
So you are using the C major backend inside libFaust.
Yes.
This one. Okay.
Yes.
I ask this because I was not remembering we put that into the libFaust version I did for you. So you were able to do that because it was just compiled with C major backend, basically.
Yeah, it was in the last Faust 2.75. The previous one was not working. I don't know what was the problem. I honestly don't remember the problem, but I said, well, why? Then I download the last one. And this is the poly wrapper file, okay? That is just wrapping the event and the gate, and is creating this wrapper, okay? So basically, again,
yes, it's a kind of architecture file, but in the C major model.
Exactly.
Yeah,
yes.
Written by Cesare for you.
Yes. Okay. So we can go to lunch, I guess. Thank you very much again.
È un tendone. Perché si sente la musica. Non riesci a sentire.
Beh, no, i palchi sono abbastanza direzionali,
Sì,
in
sì,
realtà.
mica, ma hanno dei vettoriali
Sì, sì,
incredibili.
Ah, it's my, yeah. Okay, I have to mute.
Is that me? Testing 1, 2. Okay.
Hey.
That's what you look like. I can't hear you.
I can't hear you either.
That's not good news. Can't hear you. You always get the worst technical issues at a computing conference.
Hi, can you hear me?
And you can hear me, yeah? Yeah, we can't hear you, so.
We're being guided through the private chat.
Okay. Well, this should be fun.
Yes. I'm
Nothing
excited.
I like better than a concert without any feedback at all.
The caffeine's finally starting to kick in. It's very early here. I'm feeling better now. Can everybody see the presentation on the screen?
No. Well, it says we're presenting. Ooh, that was close. Oh, that was it. There we go.
Yep, there we go. Perfect.
Still can't hear you, though.
Awesome. Okay. Well, let's jump right into it. I'm kind of nervous, but this should be fun. Hey, everyone. And thank you to the Faust team for having us. We're super excited to dive into developing Faust plugins for the Stratus multi-effects pedal. I have one right here. And we can't wait to show you what we've been up to. Let's see if it changes. Oh, it's not changing. The slide isn't, even though I clicked the little arrow.
Ah, I'm in control. It looks like I'm in control.
Okay, perfect. We'll use yours then. My name is Landon McCoy, and I'm the founder of Chaos Audio. And I'm also a very mediocre guitar player. But that's why I make gear instead. I'm a tech nerd, Guitar Hero pro, definitely good at Guitar Hero though, and love sending things into space. Yes, the photo of the Stratus pedal in space that you see there is real.
Whoa.
That was a fun project. Chaos Audio started as an accident a few years back between my brother and I. It was originally a side project, but there's a local startup incubator here that we ended up working with to bring this to life. Now we make connected audio gear and plugin software for musicians of all levels. Our flagship product being Stratus, the all-in-one stomp box.
Oh, tell me when to click.
Oh, click. Tone Shop is the online marketplace for plugins created by us, but also third parties. Fairly recently, actually. The plugins are cross-platform between Stratus and the DAW on your computer, with the DAW support coming over the next 1 to 2 weeks. There's a lot of stuff dropping in November. When we first launched Stratus, the Tone Shop started out as a closed-off ecosystem of Chaos Audio plugins only. while we slowly improved our technology and platform capabilities. Earlier this year, we finally opened up the development platform, made a GitHub repository available with basic development resources, and I mean very basic. You'll see from the screenshot that Martin shares. And some of those resources were references to Faust, because Faust is a large part of the reason Chaos Audio exists today. A lot of the plugins were developed using the Faust language. And we didn't realize how impactful that would be. I could have never imagined that 5 years ago. You can swap to the next slide.
Like a genius.
So I will quickly build a chain of plugins. All three of these originally created using Faust, actually, to demonstrate how easy it is to set these up on Stratus. So I'm on my phone here because I don't know how easy it is for me to change screens on the stream. So I'll just kind of showcase the building of the UI on my phone here. So this is the dev version of the Tone Shop or of the Chaos Audio app, because we were working on releasing some new software today, and I forgot that I have this version installed, but this will work fine. So this is the Tone Shop in the Chaos Audio app, and you can see there's multiple categories. And then if we go to the pedal board page here, I'll remove this so we can start fresh. Now we have a clean pedal board, and this is after you've connected to Stratus, and it's as easy as tapping the plus button and then selecting the first pedal that you want to add to your library. You can see all the test ones there. But let's throw in Orbiter. This was a chorus made in Faust. And so once it's in your pedal board, you can just tap on it to open it up, tap the switch to turn it on and off, and then adjust the settings just like you would a real pedal. And then you can also chain plugins together as well. So let's add an amp sim, actually, because that's launching today, to the end of that chain. This is by Ada DSP. And so now we have the tweaker amp plugin loaded after the Faust created chorus here at the front. And it's that easy. And then once you build something that you really like, you can save that as a preset and then store that directly on Stratus after you've synced your presets with the Stratus pedal. Okay. Next slide. So prior to the new Faust Stratus toolkit we're about to demonstrate, we would originally take the generic C++ interface from Faust and then manually tweak the C++ code to create the interface, which would be compiled for Stratus. It was a very messy process, but that's originally how we brought those algorithms over to Stratus. It was very gross and led to a lot of like random issues that could have been avoided if it was cleaner, but we're getting to that. The Faust generated C++ interface is the inspiration for the template we now use for all of the Stratus plugins. So with that said, I'd like to introduce you to the creator of this toolkit, Martin Bartlett, who has been a user of Stratus from the very beginning and is the reason it's now easier than ever for anyone to use Faust to develop for Stratus.
Hello. Right. So as you can probably see, well, let's put it this way. My oldest grandchild is probably just a few years younger than Landon, and my youngest son is probably older than Landon. So I'm old, but I'm glad to see Stefan there because he doesn't look quite as young as he sounds when he's typing into messaging apps. Anyway, yeah, so I'm Martin Bartlett. I'm English. I live in France, so I can speak French, or at least I can speak in a French accent. And I can show you that I do this. Play a lot of bass guitar, but don't get too impressed. That makes no money whatsoever. Everything you see there looks cool, or at least I think it looks cool, but it makes me no money at all. This is what life is really like for me. This is the reason why I don't make any money. Yeah, that's the reason I have those t-shirts. However, I do a lot of this programming, not on one of those, that's a Mac, but I do have Linux set up like a Mac, and that's what does pay the mortgage. Hold on. Yeah, so it's got back styling. I'm pretty good at this. You know, I'm a senior developer at a company called DXC, mostly financial software. Had no reason whatsoever to get into anything to do with signal processing. Had no interest in it at all. So anyway, while I was doing this, I was never one for one of these. I just, it's too complicated. I mean, I had enough difficulty getting sound notes out of my bass, let alone distorting them in whatever way. And so that was basically what I used: a compressor, an equalizer, and a chorus. And I was quite happy with that. It didn't matter where they came from. It wasn't even necessarily those brands. And I probably need one of those. As yet, we don't have one on the Tone Shop, so I'm going to have to look for that at some point. Anyway, so while I was doing for years these things, simply doing this, and I was happy with my 3 pedals. I frequently had to replace them because they tended to break. Wasn't one for investing great amounts of money in them, and I wasn't really interested in how they worked. Didn't bother myself with signal processing, as I've said. And then one day, as I was looking for ways to annoy my wife by browsing through how I could spend money on things, I came across this on Kickstarter, and it promised me a versatile and affordable guitar pedal from the future. And it's never been easier to unleash your creativity. So that sounded very interesting. It meant that I could take one of these and I could actually replace it with something that looked like that. Goes in the other direction, but there's a compressor, your chorus, and the EQ. I had them in the other way on the other one, but never mind. And there we had a problem. Oh no, sorry, that's the phone, isn't it? Yeah, that's the phone. Okay, right, and control it all from the phone, as Landon has already shown. So that did look pretty darn cool. So bring it on. And so I ordered one of those, and it truly was in the future. It's 2 years later, I think it actually turned up. Landon scratching his head there. Yeah, well, all Kickstarter projects have their little hiccups. But it did arrive. It was actually a cool Christmas present from, I don't know, 1-2 years ago. And it was cool. I actually did set that up, and it was awesome, except for a couple of things. That is the compressor, and the compressor seemed to knock off a lot of the lower end of the bass sound. And as a bass player, I kind of need the lower end. And then that's the EQ, and with the EQ, I mean, yeah, there are 6 good ranges there, frequency ranges, but that 100 hertz doesn't go down to where I want to go, and that 3.2 hertz is a little higher than my bass will ever go. So it wasn't really adapted for a bass guitar, and it was fairly obvious why, because all of these were designed for and by guitarists. And therefore, there really wasn't any service at the time for a bass. So that was a little bit disappointing, but never mind. This did work. The chorus worked beautifully. And so I did use the chorus for quite a while. I used the whole thing for quite a while. It also has a looper in it, which is really cool for songs that are kind of repetitive, like With or Without You. Play one measure and then just kick off the looper, go off for a beer and watch the band playing. So that's how it was. I didn't know how to create these effects, and I just would never be able to tell you the difference between the Fourier transform and, I don't know, the Higgs boson. I was that stupid. And talking to you guys, I feel even stupider. Anyway, then I saw this. We got a notification in the various channels that Stratus uses. They opened up a developer portal. And okay then, so I signed up, and perhaps I'd learn something. I don't know, it involves soldering or, taking the thing apart, and then, I don't know, be able to learn about Fourier transcendental Imodium thingamy, whatever you call it. Yeah, what is that? I mean, I don't know. Anyway, we went on, and I got this email, and it said, "Yeah, okay, so here you go, and there's your." But wait a minute, what? It was Linux. Okay, so it's Linux. Game on. So I started to look into this. Now, I've been using Linux since you installed it like this. For anyone who doesn't recognize that, that's a pile of diskettes. You can think of them as really slow, really low capacity USB keys. And that's how Slackware used to get downloaded from the internet onto various different diskettes. And then you'd spend the day installing it and come up with a very basic user interface. And now when I say I was using Linux, I was really using Linux. It wasn't just a hobby. It's a, patch the kernel to make it do something different and make the family use it. They were all mad at me at the time. Now they're all very happy that they all know Linux better than Windows. And as it boiled down to, a Linux device, this thing was a Linux device. Just perhaps effects development could be within my skill set. So I then had to ask, how on earth does one actually go about creating an effect? I dug about in it for a while. It's a 32-bit Pi-like Debian system with a bunch of drivers for audio things. And I found it really, really familiar because I use a Debian-based system and whatever else. So I was really happy to find this. So I then went on and went onto the portal and found that there was this link to this Faustian piece of software. So, I clicked on it and I had taken the red pill. A few days later, after diving down all the rabbit holes, I was ready to install my first effect. Now, as might be able to tell you from the image, which shows an old version of the README, the initial way of building the effect code was a bit hands-on, as Landon has said. So it was very much like that. You design it in Faust. You download you choose the generic or source artifact. I can't remember what the architecture there is. I didn't even know what that meant at the time. But I got the C++ source, and then there was some heavy massaging of the source to make it work with the pedal. Download it to the pedal, which does have at least the GCC compiler installed on it. Compile it, and then you have to install it under the effects UUID for it to be able to, for the Stratus to be able to pick it up. So did all of that, and then you had to build a UI for it on a development portal, which at the time wasn't actually working very well. So I wasn't really sort of very happy with that. It's kind of, I don't know, a little hands-on for anyone who doesn't have programming experience. I mean, it is programming, and that really was a window that opened up to me, that signal processing was basically just mathematical operations on streams of floats. And the moment I realized that, then things started to really click with me. I did figure out how I could piggyback on another effects user interface. So, for example, I actually did this. I created a 4-button effect. It wasn't this one on the right. A 4-button effect. Discovered the UUID of the gravity compressor, and then wrote my library, my shared library, into the same name, and those 4 buttons then controlled something completely different. So I knew that's how it worked, but all the same, that wasn't particularly user-friendly. So my first suggestion was to create this thing, and you just got a view of it on Landon's phone. It was the 9-knob tester. Actually, the Stratus can use, there you go. The Stratus can use 10 knobs and 3 switches. I think it's 3 switches, none of which are on there, 3 switches. But these 10 knobs, they all behave the same. They all have, go from 0 to 10. I did try to persuade Landon to do 0 to 11, just, for a bit of Spinal Tap reference there, but he didn't do it. So it goes from 0 to 10, and that actually helped an awful lot. because now you could simply install this and then install a particular effect under the UUID of this, which is the one I showed a couple of pages ago. And these buttons would then operate what you had set up in the button slots in your C++ code. So that was pretty good. But as I said, I was a little sort of ad hoc, but not very happy with the ad hocness of this. And it required the programming knowledge, and it more precisely, what we really wanted to do was figure out how to generate the C++ code in the exact format for the Stratus, but have that come out of Faust rather than having to massage it. So started looking into what that meant. And of course, that usually means try and find the repo on GitHub. Oh, and you guys are just so good. Ah, it's all open source. Oh, that's so wonderful. So I forked that, of course, and cloned it locally and started to hunt around. And then I found this. Of course, the architecture files and the Faust to whatever files scripts. And that was obviously the first place to go. The first thing we did was, of course, create an architecture file C++ template. Can't see it there. But that would allow us, and a script, of course, which would then allow us to format the code from Faust into what the pedal required. It worked more or less. There was still a bit of manual handling to do, but then that manual handling could be delegated to the script as well. So what we actually had was something that ended up being able to do this. Design in Faust, we save the DSP source. You then use Faust to Stratus, there it is, to generate the C++ code, transfer that to the pedal, compile that on the pedal, and then it's running. And that worked pretty well. And then, of course, first of all, we published that as an add-on to Faust, which meant you had to have Faust installed on your machine. But then I met Slets. Then I met Stefan, and I punched out a PR, and he said, "Nope, I don't want it in that format. I want it in all these other formats." So I said, "Oh, right, okay." So I got a little bit more disciplined with the structure of my PRs, pushed it out to the master repo. And it went live, and the moment it went live, of course, the UI picked it up. And then when the UI picked it up, you could actually do this. It would run the script for you. It would then download the code. In theory, this is what it did. Put it on the pedal, compile it on the pedal, and it works. That's in theory. Of course, in practice, it wasn't quite working like that because we have these 9 buttons, all of which are never used, but some are. They're indexed 0 to 8. And how on earth do you assure that the Faust code, the Faust generated C++ code, is referencing the same slot as you think you're referencing when you're massaging the knob? And solving that issue meant sort of really learning about some of the Faust DSP syntax itself. And the solution to that was, I think, quite clever. But you guys probably think, yeah, this is obvious. So what we did was we introduced a standard or a format that we would require for the Stratus pedal. And so first of all, up in the top left-hand corner, we added a couple of declares. So we have the Stratus UUID. So you could specify the UUID of the UI that you were targeting with your code, and the version, because there's also a version file installed. And then this is probably the more important one, is the we introduced support for the Stratus. Well, I mean, you have the support for the metadata. We're exploiting it. So we have this Stratus item, and that NN is basically the index of the button and the index of the slot. So it ties up the knob. It ties up the knob with the slot. And then that made it really easy, because then that did allow us to do this slot all work together then. That was supposed to be animated, but it didn't get animated. So now we had this plus this, and it was a reality. Mostly auto-generated backend and ready to go UI means that you can quickly test your DSP code with the pedal and iterate on it until you're happy with it. But that build step still bugged me. You still had to build it on the machine, either on the machine or locally. And so the next thing was, what if we could get the Faust IDE itself to do the build? And by build, I mean that C++ compile and link into a shared object using the architecture, a 32-bit Pi-like architecture, ARM architecture, basically, binary, which could then just be dumped straight into the Stratus with no local building at all. And in fact, you can do that. It is possible, and I have a local version of the toolkit that does that. But there was one thing. Stefan wouldn't let me. And the reason Stefan wouldn't let me is perfectly good. I quite completely accept his reasoning here. If we wanted, because what this would require is for the service, for those who don't know, the UI is split into two parts. There's obviously the UI, and there's a backing service, and that's what actually does the builds. And the backing service does already use Docker itself, and it is possible to launch another Docker image from it to do builds for whatever you want to do. But what we most certainly didn't want is don't want is a Stratus only solution. We want something that anyone who uses or tries to extend Faust and the toolkits around it can use. But at the moment, neither he nor I have had the time or the inspiration to figure out how we can police the Faust, or just these Docker files that any builder would try and use. Because as you can see by that last point, you've got a lot of danger of destroying people's stuff if you don't properly police the build itself. So we went for a compromise. So we wanted to generate an executable. Now, what that meant was having the IDE in the engine at the back generate a file which is immediately executable on the target machine. You'll see the target machine is always my Linux box here, and then be able to, and that executable would run locally, run the build locally, but prompt you for your password and push it onto the Stratus. That almost was okay, except for a couple of things. The UI didn't actually support that at the time. Even though it allowed for make files, it couldn't actually do it because the way that the IDE worked is that it required a zip file. In fact, it required a specifically named zip file. So that meant you had to unzip to somewhere and then run the installer manually, and it wasn't very nice. So me being the hacker, remember, I do a lot of stuff. I went back in to look, and yes, I love you guys. The two projects here, the IDE and the service, both open source, both easy for me to go in and start hacking around. And what we ended up with was 2 PRs. Yeah, let's say you weren't exactly being web standard between your communications, and adding location header to the backend service and recognition of it to the front end service allowed them to dynamically communicate as to what files should be downloaded once built. And then on the back end, I added a little bit of a sort of a tweak, which is documented, of course, on how to build something other than a zip file. Both of those went live, and that meant that we could now do. Oops, hold on, there we go. We could now. Did that skip one? Yeah, no, it didn't. Yeah, here we go. Did it? No, right. So this is what we ended up doing. No, okay. So the script, the point is that we downloaded the script, and I think you could see it there. No, it's probably a bit small. We changed the architecture and script files for the Stratus, so that when you selected them and you clicked on that compile button there, it would actually build an installer.sh, which you then downloaded and executed, And there you go. There it's asking for it does the compile. This particular execution uses Docker locally, but you can also bypass Docker and have it build on the pedal itself, which is a lot slower, but still works. And then a prompts for your password, and then pushes it into the pedal. And so that's where we are at the moment. We've got this really good integration with Faust. Now let's start fixing stuff. So I went in. I wanted to fix the compressor. So I conned Landon into the source of the compressor. It's NDA, so I'm definitely breaking the NDA by showing you this. I see. Yeah. So it's kind of obvious once you look at the code where that was coming from. If there is a low shelf in your chain, you probably want to remove that if you don't want to cut out the bass. So I just removed that, and now the same thing is a bass compressor. And we'll be looking into how we can actually implement that as a switch on the actual compressor, so you can do the low cut or not the low cut. That was dead easy. Once that was done, it's an amazing compressor. The rest of the source code I won't show you, but it does actually come from a Faust video. I am terrible. I cannot remember the guy's name. The French guy who basically invented it, and he must be there, which is most embarrassing. But anyway, the video series he did. And one of the things was a compressor, and this basically was inspired by that. Anyway, there you go. That's how you fix a bass. That's how you fix a compressor to be a bass compressor. The next one was the 7-band bass EQ, which is dead easy. By this time, I could really sort of go into Faust and start messing around with stuff. And another hack that I did to the UI, which I haven't released yet, is to have logarithmic spectrograms, which makes it much easier to see where your frequency graph looks like. Anyway, your frequency response graph looks like. Anyway, using a bit of that and using the actual frequency response graphs from the Boss GEB7, I designed a 7-band UI, a 7-band EQ for the bass. It's actually really dead easy, but the thing you can see here is all the Stratus bits of metadata, 0 through 6. So there's your 7 buttons, and you can see the frequencies that are there. And so Landon designed the UI. I am hopeless at UI design anyway, so he designed that, and we published it, and it's free. It's on the Tone Store, and it's free. So that suddenly we had a bass EQ as well. So I also, as a good citizen of OSS, wrote a tutorial, and the tutorial actually has you build this thing on the right. Ooh, that was a sound. I heard someone. So it allows you to build this, which is a bass amp, Traveler 400, and so it's got semi-parametric EQ, and so we use the 9 knob to build that. The link is there. If you get hold of the slides afterwards, you're quite welcome to click on that link and see how we are promoting the use of Faust in building effects for the Stratus. And so now I have also learned the difference between a Fourier transform and the Higgs boson. Fairly clear when you look at the graphs, really, isn't it? Although they do look a bit similar. There's to do. I need to work with Stefan on some scheme, because I really would like to get that build done in the cloud and have the binary just pushed down to people's machines. That way you'd have a lot less requirement for tooling on the machine, and you'd still have the fast compile, because if you build on the pedal, it's very slow. And if you build on another computing device, you need Docker. And you need to sort out the Faust IDE code. It needs a bit of love. Having dug in it, it needs a bit of love. So I might be going through and sort of refactoring it a bit to make it a bit easier to build things. And I want to implement that logarithmic spectrometer option, which of course I have a working implementation here, and my next project for the Stratas is, of course, to actually build one of these. So with that, I'm going to hand back to Landon, who will take over and show you how this all works with his shredding guitar skills.
I wouldn't say shredding guitar skills. Also, I would originally, the plan was to be at IFC 24 in person, but then I realized that it's quite expensive to fly all the way over to Italy and stay there, and decided to save that money temporarily and put that to use elsewhere. But originally, we were planning on being there and having an awesome amp and guitar set up and demoing all of this live. It's a little bit harder to do virtually, but I still want to give you a demo taking you through the process of actually the semi-parametric EQ, compiling that, building that for Stratus, and then building it, installing it on the pedal because my Docker is acting up. But it's still cool that you can build it directly on the unit. So if you don't have Docker on your computer, that still allows anybody to go in and build those plugins. So I'm going to share my screen. All right, I think it's there. So you should be able, I think you should be able to grab that. It's grayed out for me right now. My screen is. And then now we have the infinity window. Okay, cool. So here I am in the online IDE, and I actually pulled this example code from the tutorial that Martin wrote on our dev portal repository, this one right here. And so this makes it very clear. Some background, I'm not an avid developer. So if I'm able to figure some of this out, it must have been designed pretty intuitively. So I copied this DSP code here for the parametric EQ into the online IDE. And you can see that Stratus-specific metadata that Martin was referring to. We have the ID for the 9-knob tester UI, this one here. And then we have the Stratus version number, which indicates whether or not the most recent version's installed. The app actually uses that to determine whether to display installed, to tell the user that it's already on there, or if there's an update, it'll say, hey, install this, and then you can re-download the plugin over Bluetooth once it's live on the Tone Shop. And then we have the Stratus metadata for the knobs to set those indexes properly. And then you'll also notice that here, there are two different sets of these sliders. This is the slider set that we'll use when testing it from within the IDE itself. Just quick side note, the fact that it's this straightforward to go from testing in the IDE to implementing it on Stratus is such a game changer, because in the past it was a lot messier than that, and it was a lot of like manual tweaking of the code to then get it to run on Stratus. And then if there's a problem, it's like, okay, well, is it because we messed up in converting some of this code over? So it's as simple as changing this to live EQ slider, live level, and live blend if we're wanting to test here in the IDE. Which I think I can do if I come back to the presentation screen and then change my audio to be. Can you hear me now? Cool. Make sure this is outputting as well. Okay, well, I won't be able to demo the audio then if that wasn't working. That traditionally has allowed me to record sounds from the computer itself. when I'm doing screen recording. So I thought that would work here as well. I'm not sure why it's not. But anyway, so we're going to change this back to knob 9 and knob 9 and knob 9. Because that's what we need to deploy this to Stratus. So we have the Magic EQ. I'm going to export this now to Stratus. So platform is Chaos Stratus, and then architecture. I'm actually using, so my Docker for some reason is acting up on my computer. This is the downside of requiring Docker. So I'm going to use the original effect installer. So we compile it and then download that from, oh wait, let me see. Why don't we try this again? There we go. Boom. So I have the binary.zip file. I'm just going to replace the one that I've already downloaded. And then unzip that. So I have binary2 here. And then this contains the scripts that you can run. It makes it very easy to compile this and then put this in the right location on the Stratus, as well as the CPP and the DSP source code with a helpful README here that will kind of explain some of the steps to get this up and running. Traditionally, you could also, or I guess less traditionally, you could also use this original effect installer. You could use a Docker container to build this and then deploy it directly to the pedal. But again, it's not acting properly for me. So I'm going to follow the steps to build it directly on the unit.
Landon,
yes.
We can't see what you're doing on the screen at the moment. There you go. Right.
Oh, whoops. I was sharing just the window here. Hold on. All right, now I'm sharing my entire screen. Hey, thanks for chiming in, Martin. I wasn't aware that the terminal windows weren't displaying. So back to the terminal window, as well as these files. So I'm going to open this again in Finder. This is what I downloaded from the online IDE after it was compiled. So you can see we have the two scripts here. We have the README as well as the CPP and DSP source files. And this is the README that I was talking about that gives you some helpful information on getting this installed on the pedal. So I'm going to follow the steps here for building it directly on the unit. So now I'm going to go to transmit, and following those steps, I'm here in the root directory of my Stratus pedal, which you can see I'm logged in to here as well. So I'm going to delete this directory, in fact, effect installer from the root directory, and then I'm going to start over. So new folder, effect installer. Of course, you can do this from the command line as well. And then I'm going to go in and then copy all of this over just by dragging that in there. So now I have all of the fancy code directly on the unit. So I can go here after I've SSH'd in with the password. Mine on my unit is just password because I got tired of the 128 character crazy password that we generated. And so I'm already inside the effect installer directory. But we're going to see you back in there. And boom, there are our files. So theoretically, all I have to do now is run the install.sh script, and then everything will happen magically. So it's compiling directly on the unit. This will take a second. Play some Jeopardy music. Stratus, while this is running, I'll share that Stratus has a 1 gigahertz ARM Cortex A8 processor with half a gigabyte of RAM, and is heavily based on the Bella platform. So if you're familiar with Bella and Bella Mini, that is also those tools and a lot of the open source code for the Bella platform was actually how Stratus was built and why it exists today as well. So that built successfully. It was installed into the proper effects directory. So we have a specific directory for these effects with the proper name for the 9-knob tester, this one right here. And then the version was set to 0.1.0. So theoretically, after doing that, it is as simple as connecting to the Stratus pedal. So I'll actually connect from here. And then check the CPU. So we're at 6.1%. Theoretically, if I go in and load this pedal, I can't do a fancy audio demo because my audio interface is also the Thunderbolt cable broke. But what I'll do is I'll go into the app, load in that 9-knob tester, and then we'll see if the CPU goes up. We're at 9.8%. So it was that easy to get the Faust code and convert that into the binary for Stratus and then test it using the open beta development version of the mobile app. So it's very easy now to go in and test these algorithms while they're being developed until you get it exactly how you want it. And in this case, I did it directly on the pedal. I didn't even use a Docker container, and it was still that straightforward and easy. So with that said, obviously, once you've tested something, if you're unhappy with a specific setting, or you just want to go in and tweak or mess with some other things, let's say we wanted to change this high shelf to 1500 hertz instead, you could make that change, save it, and then export it to Stratus after compiling, downloading, and then follow the same process that we already went through. So it's that straightforward to iterate.
I would like to point out that because his Docker isn't working, in fact, nothing on his Mac seems to be working. That was a very hands-on way of doing it. I don't have a new installer on my machine at the moment, but I could have shown you what that looked like. But you did see the screenshot of me installing a little earlier. So.
Yes. So at the very least, the most hands-on way is still about 10 times less hands-on than the previous hands-on version. So very, very straightforward, all things considered. If my Docker was working, I would have showed the even more streamlined, just running the script on my Mac, and then it would have done everything magically and asked for the password and woohoo. But you should be able to do that pretty easily as well, following the tutorial that Martin has created. So yeah, with that said, I guess I'll pull up the slides again. I'm going to stop presenting and you can pull up Martin since we're already where it needs to be, I think.
Oh, working?
Oh yeah, we can hear you now.
Yeah, okay. So thank you very much for the presentation. It was quite impressive. And I think with Martin, we were able to solve this different issue and fight with the SLETs. I don't know exactly who is SLETs, but the devil SLETs, not wanting to install a container on our remote stuff. Well, sure, we can possibly find out a better version, but when we were discussing that, we had no idea on our side how to do this part of the compilation process in a more easy way. So maybe we have questions into the room here or on the chat. Everybody's sleeping here because it's lunch.
Put them to sleep.
It was highly disappointing because we couldn't do the guitar thing, but
I know. Well, it looks like we're at 11 minutes left anyway, so I'd probably save some extra time there. No questions?
No. Hi, I'm Jan. Can you see me? No, maybe not. But if I hello, great presentation and great product. So I'm wondering. Okay, so this is my watch. I'm wondering how the roles of the smartphone and the pedal are shared, so to speak. I thought that you were using the smartphone to program the pedal, or just to turn the knobs. Yeah, I'm curious about that.
So, great question. Thank you for asking. Stratus itself runs all of the DSP algorithms. The latency is very low. We have the Bella platform to thank for that. And the mobile app, so you can see this chain of effects here. So if I go in and add another one after the 9-knob tester, while this is connected to Stratus, what this mobile app is doing is simply controlling Stratus and saying, hey, this algorithm, load it, set it to these settings, and then also load this algorithm afterwards and set it to these settings. But Stratus is doing all of the processing locally. And so the cool part is with things like preset mode or MIDI control, because there is a USB port on the back of Stratus, what you can do is you can actually take all of these presets that you've built, up to 128 of these chains of plugins, and then store those presets on Stratus. And then in preset mode, you can use this knob, which clicks, to cycle through and bank between up to 14 selectable presets with the LEDs at the top, and then swap between preset pairs using the switch here. So once you've programmed Stratus how you like with the mobile app, this really just serves as an easy interface for anyone to use to program sounds or even learn how guitar pedals interact with each other. Once you've programmed all of those together and they're stored on Stratus, you don't actually need the mobile app anymore. So you can take this with you during live performance and then swap between those presets either with MIDI control or preset mode.
Okay, but isn't possible to use the phone also to download the code onto the pedal?
So the final compiled binary. So if you're inside Tone Shop, and I believe I'm still connected to the Stratus, if you're inside the Tone Shop, what we demonstrated was testing and iterating upon the algorithm and deploying it to Stratus to then test using a generic UI that we made specifically for testing Faust effects. What the mobile app does, the only thing that mobile app does in terms of downloading to the pedal is once you have a completed plugin. So once you've already gone through the development process and iterated upon your algorithm using Faust and the toolkit, and once you're done testing it with this UI, we actually will help create a new UI that's custom to your specific plugin, and then users can go in and install directly from the Tone Shop. So you can see it checked and that this plugin specifically is installed. But the mobile app isn't inherently used to deploy any in development, like in progress testing code. It's specifically used to just as the UI interface while you're iterating in Faust and creating these plugins.
Okay. Okay, thank you. Anyway, it's a great idea.
Thank you for listening and the question.
Hello, amazing product, really interesting. I would like to try it. Probably, I don't know if you already said it, but how is the mobile phone connecting with the pedal? With Bluetooth or?
Yes, it is Bluetooth. Now, funny story, we can't say Bluetooth on our box or on the website.
Yeah, because yeah.
Yeah, because we have to pay for that. But it is using Bluetooth.
Okay, okay. Thank you very much.
So thank you again, guys. So we will close the session because we have another remote session just after you. So thank you again for connecting and trying to do this bit shaky setup because it was not so easy to set up on our side. But yeah, and probably we will continue working together.
Yes.
Yeah, obviously.
Definitely, yes.
Thank you.
Thank you.
Thank you very much. All right. Thank you.
Hello?
Hello. Hello, Aline, do you hear me?
Yes, I can hear you. You can hear me? The sound is okay? Or
I think it's okay.
it's okay? And the image, the camera is okay? I
Yes.
move my hand and hello. Yeah. Okay,
So I will introduce you a bit. Aline Wang is a long-term Faust contributor. I think we met you like 10 years ago.
Yes.
Time you were student in Lyon. We had also the master hymn. You were student on the master hymn, and you started doing Faust development also with Christophe Le Breton, who is doing a lot of Faust development for Gram also since a very long time. And you were at that time specialized on iOS platform already with Christophe, and you presented Faust to smartphone in the first edition of IFC in 2018. And now you have, in some sense, reworked this project with Christophe last year, doing a kind of research partnership in Saint-Étienne near Lyon.
Yes.
And so what you are going to present today is the result of this 1 year work with Christophe of the LizzieLog company, long-term also contributor and worker with us, working with us at Gram on the Faust project. So it's and the project is smart and computer dynamic, Dyna.
Thanks, Stefan, for the introduction. It's very it's a pleasure to participate. Like Stefan said, I already participated the first and the second. Now it's the third time I participate the International Faust Conference. So it's a very pleasure, and I hope I can participate in person like the first time, but fly from Shanghai to Torino, it's more expensive than from UK to Torino. So for me, it's a little bit complicated. And I'm going to share my screen using my honestly, to share the screen from this platform is a little bit I think this, you can see my screen, I think. Is it okay for the audience? Yes, okay. So and for the sound, because it's a demo, so I will to demonstrate some examples. So I use some tricks to route my microphone and merge the sound from my computer, from my smartphone, from everything together, and to share with you all the sounds. I hope it will work. And from China, like the network is very complicated. So I hope the connection will work in next 30 minutes. So today I will present the SHCdyna dynamic for the short term. Oops. Like Stefan said, this is a continued development by the LizzieLog. LizzieLog is for the people do not know really well. It's a association and laboratory based in Lyon, France, for the artistic innovation and the transmission. And the SHCdyna is a continuation and extension of the Faust to smartphone project, is already presented at the first International Faust Conference in 2018. Faust to smartphone project is already generate a standalone iOS and Android Faust application for SHC projects. SHC project is for the smart hand computer. We didn't want to call the smart hand smartphone because for us, all the functionality in the smartphone interest us, but the call, the message, we don't. It's not very interesting. So for us, we don't want to call it a smartphone. So we call it smart hand computer. So SHC, in short term, is designed for a musical gesture-based musical application. And SHCdyna for dynamic is a iOS application. It allows compiling and executing Faust language dynamically from the application, and enable the dynamic loading of various compatible SHC projects. So the SHC project is including the motion capture, like we use the motion sensor of the smartphone for the motion capture, and the SHC application also is capable to customize your own user interface. So this is two core feature of SHC project. And SHCdyna is an application additionally for the dynamic compiling. So for the feature, like we said, it's a dynamic compilation, so we can execute the load the Faust code in real time from the application. So this is the slide for the interface. So we can create our own user interface. And for all the standard Faust UI, like button, checkbox, slider, what else? Yeah, we are supported, and we have some special or specific user interface, like pad, like trigger, counter, like some queue for the queue system to go from one queue to the next queue, and go next queue, like for the queue system. For the motion, it's already integrated in the SHC project from the beginning, but we are updating it, and we add some feature. We rework the motion library for the motion processing, and so now it's more clear for the user and for the performance. And for the other functionality already supported by the Faust, like OSC, is compatible in the SHC project and SHCdyna. For the installation, it's really simple. So if you have your own iOS device like iPhone or iPad, you can download from the Apple Store. So from now, I will use my smartphone, like you see in this screen, and I will go to Apple Store. So either you scan the QR code to directly go to the page, or in the Apple Store, you can type SHCdyna. So this is our application. It's free. It's free. It's free. We don't want to add some price for the application. So you can download it to your iOS device. Once you download it, it's like this in the screen. And to use it is really simple, like an application. Just we add some example piece in the building piece in the application as example. So just to show the users how we can create. So we put all the pieces of Smart Faust. For the people who don't know, the Smart Faust is a performance created by the Graham 10 years ago in Lyon. 10 years ago, there were 13 applications independent published in the Apple Store. So now we don't need to have so many applications treated by Apple. Now we only need one application, SHCdyna. So in SHCdyna, if I click my application, as you see, this is the interface, and I move a little bit. We have a 3 button in the bottom. In the right button, we have a piece. If we double click the piece, we can see the menu. So this is all the pieces building in the application. As you saw, all the pieces started with SF. So they are the pieces for the Smart Faust. So just some quick example for you. If I click SF here, I think it's so like you say, it's a Smart Faust. Smart Faust, the interface for Smart Faust sometimes it's really simple, because we want the audience just to listen the sound, not just focus on the interface. So the interface is really simple. I hope you found the. You can also hear my phone. I just to monitor the chat if there's some issue. Okay. So I continue. I just want to show you some other Smart Faust example. Like some example with audio file. If I can find some, where is SF player. So we have many sound files for the samples for this example. So I can change the sample. I can go to the which one? Sample 6, the trigger. I can emit the sample. So let's go to the one. So I rework some of the Smart Faust example. Adapted for the SHC. The last one, I think I can choose some iconic Smart Faust example, like trumpet. I'll work for now. So like as you see, all the pieces of smartphones I include in one application, and they can compile every time I click a piece. That will load and execute in real time. For the microphone, this is I must put it on the screen. This is the law of the Apple, so I have to done it. So each time I click, that will switch the example. Like you see, this is counter. To switch the sample. Okay. So I go back to the SHC UI. So this is the piece by default loaded in the application. So in this application, they show all the interface supported by SHC. Like you say, there's a pad, a button, toggle, slider with multi-touch, multi-pad. So this is the motion. As you see, there's and for rotation matrix. So this is we'll listen the Y, and go. If I go, this is the direction of a positive direction, and we go this is go to the negative direction. So like this, and yes, this is for the another X. So this is a bar graph for the visualization of motion. So this is the basic demonstration for the example. So next, the question is, if we want to create our own instrument, we call it instrument because it's not just a piece. It's an instrument for the smartphone. So how we can do it? So I will demonstrate you from Max. I choose Max for several reasons. You can choose. I will talk about later. So to create your instruments is really simple. First, you need to prepare your instrument point DSP, your project written in Faust. So the first step, you can choose your preference. Me, I prefer the Max environment, like a long time I did, and you can choose your own environment. Like this is why the Faust is really strong, because you can choose your web IDE, you can choose your text editor, you can choose many platforms to write your code first. So the first step, you will need to prepare your instruments. So for this demo, I choose example already published in the official website of Faust. So in the website, this is also a really new function in the web. So as you say, this is the Faust code, and I can execute directly in the web with the standard interface of Faust. So as you see, you are all the expert of Faust. So as you see, this is really simple. Noise for the resonator, low pass, and in the end, it's going to reverb. So also it's simple like that, and I can test it from the web. Oops. Hope you can hear the. Yeah. So there are no so much parameters, just the cutoff frequency, the Q. As you see from the web, I can every time I can change the parameters one time. So after the modification of a frequency Q, and I click gate, click to have the sound. Okay, never mind. We have our own instrument, our great instrument program in Faust. Great. Next step. In the Faust, in the Max environment, I use first gen to put the instrument, the DSP Faust, DSP code. I copy it, I change nothing. I copy it in the first gen, and then I run in first gen. And this is the interface, standard interface in Max to control the parameter of Faust. So as we saw before in the web editor, it's almost the same thing. And you can hear, I can change manually with the slider. For the reverb, I don't need to change. Maybe, yes. Okay, that works. For now, it's not so beautiful. But next step, we want to adapt our instrument to SHC. So this step, I want to use some functionality supported in Faust called OSC to send a message from message of all the interface user interface to Max, and to visualize the user interface and the parameters in Max. So this is the receiver in Max. To all the interface, I select some of the user interface. I select some motion parameters. So I want to visualize in Max, so I can show you in this way. So this is my smartphone, like you say. This is a SHC pad. So if I touch my pad, so I can receive the gates for 1, 0, 1, 0. So if I touch, it's 1. If I release, it's 0. And this is the coordinate normalized from 0 to 1 for the coordination of from X and Y. Oh yeah, I should turn off it turn off this for a second. And this is the some visualization of the pad. As you saw, this part is the for the motion. As you saw, is this part in the smartphone for the rotation matrix, as I demonstrated before. So this is the Y position, positive direction, and this is for the negative direction. So as I demonstrated before. So now what I did is just to send the message from application to Max. So the next step is really simple. I want to connect, as this cable show. I want to connect the parameters to the Faust UI. So like I active before. So now I reactivate. So now I can control with the pad. For the I connect the X for cutoff frequency. I connect Q for I connect Y for Q and I connect the motion Y X Y for the gain, as you see. So if I touch, yeah. Okay. So the final step is we want to rework. So now the sound is from the max, so it's not really really sexy. The final step is I want to put in our code that will interpret all the SHC UI. So this is the final code. As you see, I comment all the old interface, and I just copy and I add something special. As you see, this is the metadata. So this is the metadata for SHC UI to call, to use, to active the interface we need. Like you said, this for the gate, it's a pad. As you see, it's 1010, and X for the cutoff frequency, Y for the Q. For the gain, I use the motion, also a metadata. For the Y matrix of Y, positive direction. That's all. That's all. And the next step, we have our SHC demo DSP. So the next step is I want to generate the first piece for the SHCdyna. As you see, I will not directly send the point DSP file to the application for several reasons, because this is a really simple project. If we have some audio file, we have some library, so we can't send just the DSP. So I want to pack it, I want to zip it. So the next question, why I didn't use the point zip? It's a zip file. Why I changed the name to force the piece? Because in the iOS application, if the file with extension of zip, if I click it, that will decompress it automatically. So I don't like it. So I changed the extension to protect our piece. So this is a small script to do, is just to zip the file. So if I tap SHC demo, that will create a piece with SHC demo point for piece. And I use airdrop. I use airdrop to send the first piece to my iPhone. I will share my iPhone. I accepted. I put where I want. I replace because I already tested, of course. And from the SHCdyna, now I use the button load. I double click the button load and I select my, so the first one. They will have some check the code is written good or not. If you have some errors, because it's a real-time compilation, so if you have some errors, they will print error. If you are missing some sound file, they will tell you you are missing several sound files. You need to reload the first piece. Okay, so now in the menu we have our SHC demo point first piece. I double click, I run it. So now we have our interface as we designed here. So this is XY pad. I will show you what's the stands for, what's this. So I just want to check this is ready. I just set reference for it. As you see, Y for the gain. So if I go down, there will have no sound. Okay, so that is a really simple representation for the piece, and for the notation of what the metadata did, I already put in the documentation. I just show you the documentation here. So in the GitHub, I already put the documentation with the example here. Is I see in the wiki. So in here, as you see, this is the metadata. So we have a type, tab type title. We have a type for which kind of user interface you want to use. And this is the position of the interface, X, Y position, the Y's, the height, and the four last value is for the color. So all is documented here. So as you saw here is the tab is SHCDemo. This is a pad, and this is position. This is the color. Okay, as you see, the time is flying by. So the last thing is I did it just before lunch, as I saw the presentation of Yang. So I just work for another little small demonstration for the SHC. So I test the widget modulation. So it's very interesting because, as you see here, I use some demo. Well, I didn't use it. This is an example. Use the reverb, but the question is, if I want to control the dry wet mix with SHC UI, how I can do it? But before I don't know how to do it. But now with widget modulation, I can do it. So this is the piece of SHCdyna version 2. So I comment it. So now the motion, the matrix rotation did not control the gain. The gain is fixed. I copy it with a new one, and I select it as a motion parameter. And in the process, I just add this. I want my motion, like I said, the Y interface, Y direction, to control the dry wax of the reverb. So I just test it. And the last, I can generate SHC version demo v2. I think it's not a majuscule. v2. Okay. They will give me another piece. So I share. And accept it. I put and I load. Bravo. So in the menu, I select V2. So now, what's the difference? So this is the version 2. So I can't hear so you can hear maybe. So I imagine now is the full reverb. Now if I put it's the positive direction, so it's the very dry. I imagine because I can't hear it. If you can hear it, that means the widget modulation works. I hope. So that's all. That's all for the demonstration, and I think I don't have many slides before. No. Yes, I already told you the documentation is already published in the website. And that's all. That's all. That's all for my demonstration. Sorry for a little bit delay for the time. If you have some questions, we can discuss if we have some time.
Thank you, Aline. It's very impressive. So it was a pleasure to have you doing this demonstration. Maybe we should say something about how the dynamic compilation works on iOS. Basically, it's using the interpreter backend that was developed exactly for this reason years ago, because on iOS, we cannot have a JIT compilation with LLVM because Apple basically
forbid it.
Forbid it. So the way to do it was to develop an interpreter backend and virtual machine. So obviously the resulting code does not run as fast as you would have with LLVM machine.
Yes.
But the point is that you have a completely native application with a real tight audio scheduling because it's native code and it works very well, somewhat better than you would have possibly in WebAssembly and web technology when you are not always sure you don't have clicks. So this is a very interesting
use
case for the interpreter. Okay.
Yes, because yes, this is just to give more possibility for like this slide shows to you. It's SHCdyna, just an application. I think it's more adapted for the context of development and the workshops. And after the development, we can compile the standalone application just for the performance, for the installation, for because yes, just the in the face of the development, this kind of dynamic compilation is really useful.
Yes, so you mean you could even reuse everything of the GUI stuff with a pure native version?
Yes,
file version.
yes. I just quick show you that. For example, I can compile as you see here in my screen. If there's still my screen, yes. So I can compile the standalone application just for iOS and for Android. That's if you answer the question for Android, if you have some smartphone for Android, yeah, the answer is you cannot use the dynamic compilation for now for the SHC, but you can compile your own application for Android. I just quick show you from the camera. As you see, this is my old Android like this. I can compile the same application.
Okay.
Application for it's the same code. From the same code, you can compile, but you need to install Faust to smartphone. For that, is yeah. I think you are very strong, so you can also do so. So that's the point.
So, thank you again. Do we have some question? You have to go fast because then.
Yeah. Sorry for the.
Thanks, Alan. Very interesting. I want to try it. And I was wondering, I didn't understand well two things. One is max. We need max just to check the OSC parameters, or just that?
Okay.
I could use.
So this is demo. So I just want to show you what I did during the development.
Okay.
So the OSC part is just for the visualization of the user interface. So if we understand what we did, we can directly program in the code as I showed it here. So you can directly code it in this metadata. You can put it. You don't need to for the visualization. It's really, really helpful in this kind of interface. Yeah.
And the second thing is inside this Faust-Based file that you say is just a zip file with another name, right?
Yeah. Yes.
What's inside there?
Yeah, I can open it with it's only, for example, for this piece we don't have some other things, so it's just a DSP file, and you can do it manually like this. I can compress it, and you change the name or you change the extension. That's all.
Okay.
And for the pieces a little bit complicated. For example, I don't have time to show you. This is a piece created by Gamlan by Grab. So this piece we have code, DSP code. We have several sound files. So for this piece, we need to create I can compress. Oh yes, I can't find my keyboard. Yes. I just do it like this. Up. Compress directly. And I change the name. So I put, I think I put in the README and README the document. So compress all the source file, including sound library directly. You don't need to put it in the folder in a zip file and rename it. So yeah. I put in the document, I think.
Okay, thank you again, Aline. We have to switch to the next speaker, Michel Beffat.
Thank you for attention.
So the next speaker is Michel Beffat. We work with Michel since a long time also. I would say something like 10 years. And Michel is going to demonstrate recent work done with the WAM platform, so Web Audio Module, which is basically an idea of having a standard format for plugins on the web. And your presentation is focused on Faust for this platform.
Yeah, can you hear me? Yes, just before I start, if you want to participate to a collaborative demo, improvisation with electronic music and Faust plugins, you should start registering to Sequencer Party, an online application. So you type Sequencer Party, you should arrive, just create an account, and I will display an invite link that you will have to enter manually to join the session later on. So my talk is a demo. So it's a work that has been published. In particular, the last month I was at the International Faust Conference, where I had 2 papers. And these papers detail what I present now during the demonstration. So I'm not going too much into the details, more trying to make something a bit more interactive. So I will first demonstrate that we can generate very easily web plugins with Faust, then use them in different hosts, online hosts. So I will show you how to use them in a regular DAW that we developed, that is open source, that supports MIDI, audio, recording, multi-track, most of the common things that DAW does. Then I will show a real-time collaborative application for music improvisation that works also with remote people. So we will be in the room, but I know that the link has been shared also with the people from outside. So I'm taking a lot of risks because I don't remember that we tried with so many people at the same time. And then the most risky one will be the same thing, but using immersive environments. So I will need a Romain that will sit on my laptop and use an extension, a WebXR extension, so that we can show you what is happening within the headsets. And 2 of my master students are connected from France, and normally we should interact. So this one is still in alpha state, so it might crash, but I hope not. So I'm coming from the University Côte d'Azur in the city of Nice, and I'm a member of a team that is doing web stuff with Synria and French CNRS, and I work also with the W3C. I represent my university there. I'm an AC rep, an advisory committee representative, and I'm a member of the Web Audio Working Group since 2014, so I participate with people from Google, Mozilla, Ableton, the BBC, and so on, with Stefan also, who sometimes comes to the group. We participated to the creation and the maintenance and the evolution of the Web Audio and Web MIDI APIs. And my role was mainly to make demonstrators and to push the thing to the limits before making them public. So you see me with an electric guitar, so I developed a lot of tube guitar on simulators and guitar effects and so on during the previous year. During the COVID lockdown, with Stefan and another group, a large group of people, about, well, between 10, 12 people, we created the last version of the web audio modules, these web plugins, and they were designed to support many different languages for developing them: JavaScript, TypeScript, using build systems, C Sound, Faust. Now we've got C major support also, and so on. And this is just a subset of what is available. And here you can find some instruments that are cross-compiled from C++, from Juice plugins. Some of them are written in Faust. Most of them are written in Faust, actually, as you will see. This is some guitar amp from the Guitarist project that use also Faust and so on. So I've got a list of an incomplete list of the web plugins, the web audio modules that are available. And as you can see in this list, most of them are from Faust because it is so easy to export from Faust. You see this line, Faust, and you will find many audio effects, some instruments, and nearly none note generators. So except some random note generators, but I will come back to this after that. So it's very easy to export from the Faust IDE. I've wrote a guide, an online guide, where in some seconds, if you are reusing an existing code, you can make some Faust plugins. So for example, this guitar amp here, sound. Okay, it's written in Faust, and I just recreated just in a few seconds earlier. I had a code here. I clicked on the compile button. So the plugin is here. And using the UI builder that you activate by clicking on this small wheel and enable it, you can tweak it in a UI builder. And when you export it, it's already published on the server. In real time, it's published. It will have a URI. You can try it here. You can download the zip file. And if you try it interactively, you can try it with the UI I customized or with the standard UI from Faust. Both of them are usable. And the plugin is just a URI. So if I take the URI from here, I copy the link, I can just copy it and paste it in any compatible host, and it will work. It should work. Well, I don't know why. Maybe it, let me try again. This is a bad, okay, there is a bug, so I'm taking some risk with the demos. But normally it should work, okay? And you can, we have many different hosts today that I will show to you where you can reuse such plugins. So for example, this the plugin that was shown here. Okay, I think I lost. Yeah, the plugin that was shown here. This one, the guitar amp scene. You will see it in a DAW in a minute, and it's available, well, in a DAW that I will demonstrate called WAM Studio. If you create a track, then you can load the plugins, and you will find many plugins. About 80% are written in Faust, and you will find back the guitar amp that you can use to record and to make your own project. Okay, so I'll come back to this tool in a minute. So, can you do it online? That was the title of the paper I presented the last month. Yes, you can do it online. And I will show you an interactive demo, but we taped a small movie where with this particular amp and other effects, we recorded two instruments at the same time, along with a bass track, along with a drum track. And it was in sync, because when you do this on the web, you need to do latency compensation and so on. So we've got a DAW that is doing all this. So you got the idea, and now we've got a full MIDI support also on the DAW. So in this DAW here, you've got some Faust instruments. Let me find some. For example, where is it? Where is it? Okay. Yes, you've got the famous Faust flute that you can try. And I can record this, I can record this using a virtual MIDI keyboard because we don't have a real one. So if I start recording, and the sound is coming out from my, what should I do to have the sound going out there? Output device, HDMI, I think, yes.
No, it's a headphone.
No, headphone, yes, you're right. Settings, where is it? Oh. No input device, default, my, where is it?
Output, the other
I am in the input. Okay, output. Sorry, I'm sorry. It's there. So yes. So I can. So yeah. Okay. So the music I recorded was not so good. And by the way, talking about performance, this DAW is open source, and it was written as a demonstrator for web developers who wanted to use, with high performance in mind, web audio. So all the communication between the DAW and the plugins here is done using shared array buffers. We don't have to compensate anything with the MIDI because the MIDI is very low latency for input and output. And we are not sending MIDI events from the DAW to the plugins. We are just sending the data, sharing the data using shared array memory. So it's nearly instantaneous and doesn't require any allocation, memory allocation. So, and you can do all the automation here. For example, I can automate any parameter at the I think it's the A rate here. So you got the idea. So let me go a little bit further. So time for the real-time improvisation. So if you created an account on Sequencer Party, I will show you an invite link. So please join, but don't do anything until I explain a little bit how it works. So this is the URI. It's a tiny url.com bdf3fry6. Okay, so type this in your browser. You need to have an account. The web audio module, and some audio module will be in Faust. I know which ones, but yes? Yeah. And then when you enter that, you need to accept the invitation, and then you click on the demo session. Click on the title, and you should be able to join. Okay, so the idea here is that collaboratively we can move add, connect, disconnect, remove, tweak the parameters of different modules that we are going to add on the fly. And each module is coming from a URI. It is not something that is hard-coded in the application. So I can even add web audio modules that are not in the menus, as you will see. So for example, I already created a piano roll, but let me start from zero. If I double-click, and you will be able to do this too in a minute. If I double-click, I've got a menu that appears, and usually you start with some note generators in the MIDI menu, and I propose to start with the piano roll for the moment. The function sequencer is something also very interesting, but I will show you it later. So I created a piano roll. You can zoom in, zoom out if you like. I'm going to add an instrument, double-click, instrument. I take this one, for example, Spectrum, add. You click on the small red output. There are some squares. Red means MIDI. So you click there and you connect it to the instrument. And the blues means audio. So from there, you click to track output. And if I add some notes here, and if I play, and you can do this locally too, it starts playing. I change the sound here to have something more. Okay, so other people are doing things, I don't know. Yeah, we connected the second piano roll. Yeah, then it will send all the notes twice. From there, you can also connect some effects. So I'm double-clicking, go to Effect. Let's add a delay or no, a reverb. So for example, we got a reverb here, the Greyhold that was shown by people from Fausto. I don't remember the name. Yeah, Domenico. Yeah, let's add the Greyhold that is a Faust reverb. I connect the output here to the Greyhold and the Greyhold to the output. And then if I play it, I've got something different. If you go to track here, you can work on other tracks. And I suggest that if you are together, a group of two, or you do things on other tracks, not to pollute too much what people are doing. First, work on your own track, okay? So from the second track, try to do the same thing and experiment. I am normally the master of ceremony here, and I am the one who is streaming on Twitch, on YouTube, and getting some money from there, you know, trying to attract, to gain celebrity. And so that I can control something that you cannot control is the video. So I can also add some nice web audio modules for controlling the video. So here I added WebGL shaders that will move with the music, okay? So I can connect the output of my chain to this thing, and then it will react to the music, okay? I can also add some WebGL shaders. It's in a video shader. I can add this and connect the output of the video to the video shader and the video shader to the track output. Then I will have also the video that will be tweakable. Now I would like you to participate. So let me go to the second track, show you just a last thing. After that, we have 5 minutes of improvisation. So I double click, I add a step sequencer, or maybe, yeah, function sequencer, for example. I add it, and I can use it with the default value or click on factory, and I'm using, yeah, a variable length drum sequencer. So this is something that will be configured only when I add a drum sequencer. Drum sequencer, I connect it to the drum sequencer to the output, and then I'm adding some kicks, you know. Okay. And I can mix. Okay. So start playing with that. And Stefan, you will certainly recognize in the effect that most of them are Faust-based. Yeah. And okay, so I'm going to put play on. Maybe you reduce a little bit the volume. It's me. Okay, so it's me. Yeah, and I would like you to start doing crazy stuff. Okay, for maybe we got 5 minutes, so experiment. Okay, and after that I will tell you how this thing works. I'll go back to track 1 and maybe use some different effects or instruments. If I click into for developers here, I can create a new Faust plugin on the fly and add it. What do I have? I've got some instruments here. Clarinet, yes. Let's use the clarinet MIDI, for example. Clarinet MIDI is here. Okay. I export it. Okay. I will use not this one, but this version that looks better. It's called standard UI, I think. Copy the link, and then I can add the link. I click on for developer, and then I have the clarinet MIDI here. And I can use the clarinet MIDI to generate notes too. I can disconnect this. It is only the clarinet that is playing, so maybe stop that. Okay, the clarinet is a bit strange. So I can. Okay, what people did here, let me look. So, okay, here we've got a drum. Here we've got track 4. This one is unfinished. This is a work in progress. So let's add a step sequencer here. By default, okay. It's disconnected already. Okay. So let's add some notes. Ooh. And what is interesting too is that here this thing can be coded collaboratively, and we did collaboratively code some of the version of this step sequencer. This is Visual Studio Code with a collaborative extension that I will explain. Okay, so I don't have much time for the rest of the demo. So now, how this works in a few words. Every plugin has a state, and the state is considered as a text document, and we are using the same algorithms used with collaborative text editors. There are two families of algorithms. One is transformation of operation transformation. The other one is CRDT, and we are using this last one for doing the synchronization. And here, it's done using peer-to-peer connections, but with a special peer that is in fact running on Node.js, and that is persisting everything every minute. And the states are synchronized every 3 seconds. So just to end with something a bit crazy, we decided to do this with VR headsets. So here I was with my students, and we are using exactly the same plugins, but we are generating the 3D UIs on the fly. We are asking from the UI, we are downloading the plugin, not instantiating the UI part, asking what are your parameters, and from the description of the parameters, we generate some UI with draggable cylinders for the parameters and so on. And here, I can see a video, but I will do it in real time if I get 3 minutes. I will need you, Romain. So all the avatars you see are the different participants, and you can position, rotate, move, connect, disconnect different elements. And these are exactly the elements you saw. It is the piano roll simplified UI. It is okay, you can sit down. So you see the ID. So we've got different people manipulating this at the same time. So let me go a little bit further in the video because you can see what other people are doing. So from the menu, you can select node generators, audio effects, or instruments. And you can also position an audio output that will be spatialized. Okay, so you've got the ID. So let's try it for real and cross our finger. So what is happening is that Romain will run it, I'm closing a little bit the thing that can use too much resources. Okay, so Romain is going to the musical metaverse onrender.com website. But in order to run it, we installed an extension for WebVR. So let's run it using WebXR. And from that, oh, people are already there. So you can use virtual joysticks. I don't know what is this tube, but here you can see people that started to build some installations. They are my students. And so Romain will act as a director, a movie director, showing what is happening. And I will use the headset. I will use the VR headset, connect, and try to do several things. But I won't see you, so you will have to guess who I am. So yes, okay. So I take the. Well, just a second. Okay, I think I will remove this. Yes, I am in the link. Okay, that seems good, but okay, I don't see my browser. I don't see anything anymore. I'm lost. What is happening? Okay, you're in front of the projector. Yeah, but just go back here. Okay, let me start. I start again. I need to confirm, the limits and all this stuff. So let's click on it. Yes, I am in. So okay, we see you. I see all the other ones. So let me move forward. Maybe you will see me. I will go close. Yeah. Yeah, you located me. Yeah. Okay, so let me create something. I press on the new. I create a new node generator. Yeah, it's in front of me. Can you see it? Yeah. I will move it a bit above, maybe rotate it a little bit so that I can see something. Yes. I put it here. Okay. So now I'm adding some first audio effects. So let's add a pre-roll. So, okay, down on the right, this is the pre-roll. Maybe come back close to here, so you can see the name of the different parameters. Yeah. So I will just lower the feedback. You can see it lowering. Yeah. So I lower the feedback, and I will connect the step sequencer to the pre-roll. So I position it a little bit on the right. Okay. I move a little back. Okay. Now I will connect the step sequencer to the pre-roll that I'm moving, and I will add an output also. Audio outputs. Okay. Position it somewhere so it is specialized to the set like that. And now I can add notes. So okay, the sound is always the same because it is a prototype. You don't have many different instruments, but you can get the idea of what we are doing here. And I can also go in there and mess up with the other installations. So let me remove most of the nodes from there and add new ones. Maybe I can tweak what the others did, the installation, the rotation, and things like that. So you've got the idea. I think it's too late. It's not late. Yes. Okay. So it works. So this morning, in 5 seconds, he had managed to break it. Okay. And I can go somewhere else and I can do the same. So I can go further there. So this is a stretchable here. The tube. There is a tube in the middle of nowhere. And I can yes, we are adding more and more instruments because maybe you noticed that we had only one connector for each plugin. And in the 2D version, we had 3 different type of connectors for audio, for MIDI, and for modulation. And here, so far, we just yes, we are working on it to add parameter modulations using 3D orbiters and physics engine for generating notes, random notes, you know, with collisions, for example, and so on. So, thank you. Yes, questions. Yes. Sorry.
Going to escape some questions.
The time went so fast when I checked the time.
So we are very close to be able to use widget modulation in your with your plugins, so to speak.
In sequencer party, the 2D version, we are doing modulation, but from the an external point of view, using parameter modulation, parameter automation.
Okay.
But as Stefan said, I think it's at the quantum rate, not at the audio rate.
Okay.
And well, if
because you just have to drag the output of something to the value of the cylinder of some parameter and decide that this is the way to do widget modulation.
Yeah.
And recreate on the flight the
with what you showed, we could imagine recreating on the fly the 3D,
yes.
the 3D GUI. So a lot of work is being done right now. Right now, we are making a state of the art about how to use instruments in VR. We are developing some interactive editors for generating, but with customization, the 3D GUIs. I didn't say that, explain that, but we've got some mapping files where we can hide or group parameters together, like in macros, for giving having just one controller for multiple parameters. This is already usable, but you need to tweak the configuration file by hand. And yes, what you showed, obviously, we'll have an application here. But for modulation, I really would like, with this kind of application, to use also 3D specific stuff. You know, like orbiters, like volumetric sensors, and things like that. Not trying exactly to reproduce what we have in 2D, because we tried this and it
doesn't work.
Yeah. Doesn't work with this application where you move in a large playground. And yeah.
Okay.
Amazing, thanks a lot. Is there support for multiple audio output, or is just stereo?
The problem with the audio output in the headset is that you don't control the hardware. So so far it is specialized using the speakers from the headset, and using we tried also audio inputs, but really the sound cards there are really bad. And we try, not me, but I know people who published a paper, okay, that was presented also the last month. They compared the hardware of all the available VR headsets, and everything is bad for computer music, for example, for interactivity and for latency. So this is why we are generating notes and not using real-time inputs there.
Okay, thank you.
But yeah, it should be something that well, it would be cool if we could have some better hardware there.
Yeah, but also like connecting a sound card and use it just sequencer party, you can.
With sequencer party, yes, we can. You can use external stuff. Well, for the moment, we don't. We use the default output from the system.
Yeah.
But with web audio, you can choose which output. You could do a 5.1, 7.1 if you like. This could be possible. It's just a matter of developing a plugin for the output.
Okay.
Because we know already how to talk to external hardware from sequencer party. So there are some plugins that control some Korg Reels hardware synthesizers, or can control some lightning. We've got such things with OSC. Yeah, it's just a matter of writing it.
Nice. Thank you very much.
So if you look at the schedule, we now have a roundtable on DSP and libraries in Faust. So before we start doing that, there is something very important that I wanted to tell you about in case you are not aware of this. So if you really enjoy going to events like this one, and you want to go to a similar event to this one in a place very close to here, we're actually organizing Linux Audio Conference 2025 in Lyon on June 26th through 28th, 2025. So it's very similar to this conference. Well, it's much bigger. There are many more people involved, of course. There is a call for papers, which is peer-reviewed. So it means that it's a little bit more rigorous than the way papers were selected for IFC, where we basically just took all the papers, you know, and then, you know, like, so for Linux Audio Conference, it will be a little bit more strict, you know. So yeah, if you want to submit a paper, the submission deadline is March 24th. Linux Audio Conference is free, so like it's a cool thing about this conference. You don't have to pay to attend the conference. Yeah, and it's going to be cool. There is going to be concerts involving spatial audio systems. There is going to be a live coding concert at the last day of the conference at a club in Lyon on a rooftop. So it's going to be really cool. It's going to be a big event, basically. So another thing is, if you speak French, you can also go to the Journée de l'Informatique Musicale, which are going to take place just before Linux Audio Conference. So we're basically doing a combo, and so basically the Journée de l'Informatique Musicale will take place first on June 23rd through 25th. And they will be followed by Linux Audio Conference on the 26th through 28th. So yeah, so basically, if you want to do one full week plus one weekend of audio conference, come to Lyon at the end of June. And again, like, Lyon is only 3 hours drive from Turin. So if you, well, 3 hours and a half. So depends who's driving, I guess. But but yeah, so we're pretty close, you know, and so this should be a cool event. Cool. Any questions about this? No? Okay. So now the DSP and libraries session. So this is supposed to be a roundtable, so I didn't really prepare anything, and so the point is that we all talk together about this. So before we do that, maybe I can say one small thing just to get things started about Faust libraries. So you know, like, the Faust compiler and the Faust as a language, we don't really get that many external contributions for things like this, but the DSP libraries in Faust is really a big community effort, and so in fact, most of the functions that are implemented in the Faust libraries, they are. Something happened. Okay, it's back. Okay, so yeah, most of the Faust libraries were implemented by people who are not necessarily at Graham, you know. And for example, Julius Smith is one of the main contributor of the Faust libraries, as I'm sure you know. And so so there is really like a big community effort towards this. So. Jan told you about the new semantical features that are going to be implemented, well, that are now implemented in Faust, you know, like on demand, which is probably going to change a lot of things in the way libraries are implemented, and also in terms of what can be implemented, because as we discussed yesterday, we're now going to be able to implement like FFTs or convolutions or things like this, which was not possible until now. So this very new little thing is really going to make a huge difference, I think, in terms of what can be done with Faust, basically. So no, I'm just gonna. This is to start the conversation, right? So now I'm just gonna give my opinion on one thing that's maybe missing to go again to the next level, and this is something that we're very much aware of, in the Faust team, and we I mean, people thought about this for a while, but there is no proper solution. And for example, it's the ability to express linear algebra and matrices operations in a way that makes sense in Faust and that completely fully integrate to the language. So I feel like on demand is a big step forward. But if we can express matrix operations in a way that makes sense for people who do this normally, then I think we can really just do absolutely everything, and so I thought that maybe that was a good topic to start talking about. So does anyone want to say something about this? So bye bye. Maybe you want to say something about this. So any thoughts on linear algebra in Faust and our ability to express matrices? So maybe to give you some more background on this, we like a couple of years ago, we had an intern at Graham who worked on this, and his name was Riccardo Russo, and he's actually from Italy. And so Riccardo managed to express things that normally involve matrix operations using a cellular automata way of writing things, and it was kind of a workaround for not properly expressing matrices operations, and so I think that if we one day are able to do something like this in Faust, then we can really do absolutely everything that's out there, and I'm sure Pierre, you would strongly agree with something like this, and so maybe this is one way to start the conversation. So, do you have any thoughts on this, or do you know what I'm talking about? Tommy, and maybe we can give the microphone to Tommy. Stéphane, there.
One, two, there we are. Hi. Could you give us a brief overview of what's missing? Because I'm aware that, okay, so we have Riccardo's work, and also from trawling the libraries, I know there's a dot product function somewhere. I can't remember which library that's in. So there have been some efforts in this direction, but what are we missing?
For example, how would you write a matrix inversion in Faust? Or something like this, and how would you do this kind of operation in Faust in a way that's sort of seamless, and that doesn't involve torturing your mind in a way that's over complicated, that's and
Stop giving me ideas for side projects.
And maybe there is a way to do it, but I feel like every time we tried to actually express this kind of things, so basically represent everything as a big table, and try to move things around in this table, and then have many indexes and read things through indexes. So Stéphane and Romain, hi. I think something close to the true autotune algorithm could be implemented in Faust. See the ADC22 talk by Xavier Riley for a clear overview. Okay, so maybe we can talk about that after that. So it's I don't know. It doesn't say. David Brown. Okay. well, what I'm saying here is just food for thoughts, like so. But is there like this is supposed to be an open discussion? So. But and I know that Anna, you want to say things, but I'm saying I'm saving this for in case we really run out of things to say. So.
The problem is, for me, is the fact that you can already more or less simulate. Basically, you build a circuit that do the matrix multiplication, for example.
Yeah.
But obviously, it's not very convenient. So you can solve the problem by providing some library that do that. But as soon as you start looking at the block diagram, it's going to be horrible. So maybe the solution is to do the trick like we did for the FIR and IIR reconstruction. The difficulty is the fact that if you provide these high-level primitives, it's going to be super nice and useful, but at the same time, you would like not have two different ways to express the same thing, so to speak, that they should end to the same. So it means that anyway, if you express this using the current Faust, it should be reconstructed using this. So basically what I'm saying, it's a little bit confused, but I think that if we introduce this kind of high-level functions, we need to be able also to reconstruct this from the low-level function, so to speak.
But maybe it's not a question of implementing a high-level functions. Ideally, you would want to be able just to write that in plain Faust, and currently it's hard to. It is kind of hard to do it right, and so.
Yes, what I want to. For me, the example of the FFT written by Julius is a super nice example because even it's written in a different way, but it's super elegant. So, well, I don't have precise things to say, but
me neither. I'm just.
It was just to
it was just like
open the discussion.
Yeah, to open the discussion. We've been talking about this for a very long time. So since we don't really have like a clean, proper solution, I feel like we that was maybe someone in the room has a solution. So.
Hello. No, just would it be possible to do those kind of complex operation with foreign functions? Like we already discussed that, but I mean for the compilation stage, like you describe your algorithm, which involve inversing a table of numbers. You just call a line a foreign function in Faust, and when the compiler needs that to retrieve the numbers, then the signals are computed.
It would be possible, but then like for example, how do you do this in the Faust IDE? Because
I don't know. It's your job, not mine.
No, but like. I
use it.
It's true that it's possible to do it. Like you could use any like existing C++ libraries that takes care of doing matrix operations like CBLAS or you name it. But it's already possible to do it. And but then if you do it, you can't really prototype things in the Faust IDE because then you create dependencies, and those dependencies require like special like compilation chains, and everything. So I don't know. So, but yeah, like that, it is potentially a backup solution if you really wanted to do it.
Okay, you'll show me how to do.
Any other thoughts on this? Yeah, maybe you can come here.
Maybe this is not about the library development more, but one difficult thing when doing complex operation using Faust is that you can't give a name to the data type. Like for example, matrix type has there are very different type of matrix. Of course, you can, for example, you can do a basic operation for the complex number in the Faust, but user usually cannot know if the function really takes a complex number or not. It is really difficult to expect. So maybe this is the overkill solution, but what if we could have the TypeScript, but it's Faust version?
Jan, maybe you want
to. maybe this is sort of the compiler guy.
Well, I think you are right, and but how can we do that? So the idea is that in a normal programming language, you are able to describe types and data structures. In Faust, you can simulate the fact to have complex numbers by using two signals, so to speak. But you cannot enforce the fact that you need these two signals and that they represent complex numbers. So yes, it would be a large step, and we need to find the fast way to do that. Currently, everything is anonymous, so to speak, including types. So it's a problem. But maybe, I don't know if we can use the same trick that as circuit operations. So for example, let's say that you give the convolution, 2D convolution circuit, and then you say, okay, generalize that to a matrix of 100 by 200, for example. No. So I don't have a real answer, sorry. Yeah, I agree.
We have a suggestion from David Brown online, but I'm going to read it, but it's the same as Pierre, basically. Like he says, I think, oh, no, okay, that was a different one. Okay, it changed, sorry. Okay, yeah, so yeah, the other one we already replied to it. So now it's, I think a real-time Kalman filter is a little more possible now.
Why?
David, why? Okay. Yeah, and the other question was, is a foreign function possibly the solution to matrix inversion? But yeah, so that was basically Pierre's suggestion. So. Okay, so, oh yeah. If you don't have more suggestion on this topic, maybe Alain, you can take the. I know, no, but the whole point of the whole point of this session is to have an open conversations on various things related to DSP and libraries. So, and
yes.
maybe you want to.
I think what we miss when we considering using Faust and teaching Faust to composers, a public of composers that feel the necessity of not only using plugins or any prepared software, but starting doing things by themselves, starting patching first in pure data mainly, and then starting with us to learn and practice Faust language. I think we need a new library oriented towards composition, and in the meaning that providing a very good level of examples of modules coming from I would not say professional composers, but as we have seen yesterday with the Granulator by Pierre and José Miguel, or this morning by David and other processes, synthesis or processes. I was even thinking of the necessity, for instance, to include major inventions, such as, I don't know, for instance, the bell by Risset should be in this kind of thing, because it's kind of model. The path, the phase align formants by Miller Puckett should be there. So high level processes, functions directly that composers can directly use, and knowing it comes from professional practice of composing, and I think we need that.
Oh, anyone wants an internship? Yeah, no. I mean, I think it's a very good suggestion. It means that we need someone to do something like that, and
yes, to make ABC lib, we had our personal mixed music lib, mm.lib, but I think we should enlarge the area and work collaboratively with Pierre, with José Miguel, and maybe propose other people to join us and make a contributive and collaborative library. Well, I think we can start something and make a kind of call to people, an official call to people, and try to collect first step of answers and try to put everything in order with the right documentation as it should be to describe each Faust function, etc., etc. And after maybe propose the new library to you to include it in the Faust ecosystem.
Okay, so Michel, you are going to lose your head. So what I want to mention, and Stefan mentioned it, is the fact that we are going to have a package manager. And so this is going to be super important for the development of libraries. Currently, if you want to provide a library, it has to be included into the standard libraries, which is not super convenient. So the idea is to have a package manager. So basically currently when you can import, you can have library and you have components. So in these three operations, you specify the file. But with the system, you will specify a URL with the proper version. And so you would import that. The system will first import it from GitHub. We will have a repo on GitHub, then store it locally. And so if it's here, it will never then be downloaded again. And I'm in the middle of the, okay.
It's always your belly on the screen.
Yes, okay, so it's not very, tu t'aurais pu me dire quand même. Everybody would be more able to collaborate to provide the libraries with this system. So we hope to have it in the current of 2025. And I will also, I have started demonstrating. Of this center, yes. I've started demonstrate this modular.lib, and so I'm going to make it publicly available. And so I require proposition and contribution to this library. So if you are a user of modular synthesizer, you know the kind of module that could be nice to implement. And I think none of these modules are very difficult to implement in Faust, so it's going to be useful to have a library. Maybe reproducing existing physical modules would be nice to have.
But yeah, to continue on what you said, Alain, I think that maybe having a list of things like what you described that should be implemented. And maybe just finding, I mean, because there are some of them that we might be able like to do like as contributors, you know, like we're like, okay, today I'm gonna do this, and then I will push it to the Faust distribution or something like this. But then I think having a slightly more systematic way of doing this, you know, and maybe like finding someone who's paid to do it, you know, like, and maybe it's an intern, maybe it's more than an intern, you know, and I mean, like, you know, back in the days, and it's not so long ago, now it's pretty long ago, like and that's how I started working on Faust, you know, I wrote the Faust SDK. And that's basically what it was, you know. Like, I mean, so there were no like physical models in Faust, you know, and there was a need, you know, and then I did an internship, and then and then I wrote the Faust SDK, you know, like so maybe we like it could be something like that too, you know, like and like it's just a matter of finding someone to do it.
Someone like you.
No, but like I'm sure there are many people in the room who could do something like this, you know, like so. Yeah. Any other suggestions? Do you think there's things missing in the Faust libraries or things? So yeah, that's a good question. I mean,
part of the answer is also that maybe we don't have it anymore. We don't need it anymore because of the widget modulation IDs, which is a way to avoid to have to do this explicitly. Because, for example, in the physical modeling library, you did that. Probably it's only libraries that does this distinction between each algorithm with only parameter and then the UI version.
Yes and no, like, because basically this started, you know, like I forgot when it was, but like 6 or 7 years ago, we completely rewrote the Faust libraries because things were becoming a little bit messy, and then we tried to standardize a little bit more the names of the functions in the Faust libraries while writing some documentation for it. And so at the time, there were functions in the libraries that Guido wrote that had user interface elements, and others that didn't. So at the time, we were like, okay, so we're gonna try to make some kind of convention for this that functions that have a UI and that are ready to be used will go in demos.lib, and then the other functions without user interface elements will go in the other libraries. We didn't really do this for the physical modeling library because it's a very, very big one, and there are so many functions, and some of them can't really be used standalone, which is not the case of demos.lib. So yeah, things are pretty messy now that maybe
not sure it's more messy than it was before, but this work has not been done completely in some sense.
Yeah,
so.
And
what to say? I don't know.
I don't know. Like when I wrote those libraries, like I tried, because the problem with user interfaces is that they can take a lot of space, and it quickly becomes hard to read. And then you have like a mix of user interfaces that are like very heavy and very thick, and in the middle you have one line of code that does DSP, and so I guess it's a little bit up to the people who wrote the functions for the Faust libraries to be careful about not writing code that's not too dirty. But yeah, I'm not really sure what else could be done about this. So yeah, maybe.
So I think it's a good practice to separate really the algorithm from the user interface. But having the user interface is also a way to document the algorithm, so to speak, because you see what are the parameters, their ranges, etc. And now that we have widget modulation, I think that we should really provide the library with the algorithm, an example of a full user interface, and then you can reuse that very easily, because you can just reuse the algorithm, reuse the full user interface, customize with widget modulation your user interface. So this is the way I see the future of the libraries.
I've got a modular synthesizer in front of me here, a virtual one, and maybe we need to improve the widget set. When I see that, because you can have vertical labels, you can have if you want to visualize the wires, the cables, maybe, I don't know. I talked this morning about visual feedback. It should be either with automation or some bar graph animated, but knowing what is the source and what is the target is also important. And usually you've got also some matrix modules where you plug, you wire everything. And having this, maybe you need some holes to plug patches. I don't know. In terms of user experience, I think there is some work to do. If you want to do modular stuff.
Yes, but this is maybe this is something interesting, but it's a bit outside of the DSP code in itself. It's more of GUI. Or maybe it's how we the question is what to do with the decision we took years ago to have this concept of abstract UI with a set of predefined slider button, and then we added and the grouping system that allows possibly an architecture file to do some kind of layout, and then we added the metadata ID to customize a bit. But yeah, we have the kind of limit in what we can do with this model, or we would need to extend with a kind of CSS like model to really change the behavior. But then it starts to be outside of the language. In some sense, it's more an architecture question. So
I agree with what Stefan just said. I think that we have the real user interface of some application like this super nice modular synthesizer and the abstract interface described in Faust. I'm not sure that we can find a way to have an abstract description that fits the model of modular synthesizer. I don't, but maybe it's just a lack of imagination for my part. But sure. But yes, but what I'm trying to say is that the fact that this is the part of the application, and then I don't see how you describe this concept into the abstract description of the user interface, which part of the Faust language. It should be described in terms of metadata, saying, for example, okay, this is a candidate for widget modulation. So we have a metadata, say, voltage control hole, for example, that you place in the label. And then the architecture file, this modular synthesizer will read that, know that this is a modulation hole, and that it's a candidate so that the user can connect an output to an input at this point. But yeah, but you need to explain me. I don't see how you can do that, but okay.
Yeah, just an alternative that we've been using in ABSLib and BBDMI that Alan proposed me. I don't know if it's already integrated in the Faust libraries. Is that we always develop the naked objects with all the inputs, and then just after that, we develop the same object with UI after it. So we have all the controls. So if you call the UI, you get the beautiful interface with the V groups, H groups, all well organized. And if you want to use just the raw object, you just call the abstraction without the UI. So we always create both of them. So you have the GUI, but it's separated from the main if you want to use it in a bigger structure. So you just get rid of the GUI. So yeah, I mean, it's an alternative that Alan told me to use, and I think it's kind of practical.
Yeah, this is exactly what I was saying.
Okay, as far as
yes, this is what I was saying, to have the algorithm, so to speak, the naked object and the one with a rich user interface. So, and so it's a good practice that you already have, you are using. So it's what we should follow, this practice here. And it makes even more sense now that we have the widget modulation, because we can reuse part of the user interface.
Any other topic you would like to talk about, which is related to DSP and libraries in Faust?
The power by Faust-Based was quite valuable for me, because I grabbed many examples to clone GitHub repos and try to find my happiness there, and I learned a lot by looking at examples. So maybe I'm not a good student because I never read the documentation. I prefer to read the code and see, hey, let's tweak that, let's tweak this, and yeah. So if we have more resources like that, and adding also, this morning I asked to Alain, I said, we've got plenty of examples in Faust, but not so many instruments. I mean, we've got plenty of instruments, but that are not very, you say, don't take it bad, but not very complex in terms of many modules, you know, like a big synthesizer, for example. We've got the Mini Moog, we've got some, the Juno 6, but I didn't see any recreation of real big ones like the Pro 54 by C Major, for example. This one has a 1000 presets, very different. It draws a very different kind of sounds, and it mixes well, different techniques there. So because I'm using some instruments to test the DAW, and well, the ones I found, they sound very well, like the flute, the physical modeled ones. But for classic synthesizers, I couldn't find many. So maybe if people created some instruments, please share. I don't know.
Yeah, I mean, it's always the same with that kind of stuff, you know, like this. So someone has to do it and just and just like be like, yeah, I'm gonna contribute and post it. But yeah, it's hard to have like a systematic approach to this. It would be nice, you know, like, but then maybe we would be like a company or something like this. But yeah. Well, maybe if we don't have more things to talk about, we can switch to the next session, because I'm sure we're going to have a lot of things to say, you know, and then... Cool. Okay. Well, so Stéphane, Jan, maybe you want to...
Uh, 8 minutes more, because the next roundtable is supposed to start in 8 minutes, right? Probably they are not yet connected. The guys from Expressive. Yeah. First, I think they started by developing this touche hardware set component that has 4 axes that you can connect to. Okay. First, the touche hardware. So it's a 4 axis pedal. How do you say that? Supposed to be connected to your instrument or your DAW or your synthesizer. I'm completely improvising, so I don't know what to say. Sorry. Then, more recently, they started, they released, I think 2 years ago, the Osmose keyboard, which is basically a keyboard using the same kind of technology they have for the touche things, but for each key on the keyboard, so that you can, maybe we can have a look. Very sensitive keyboards how I'm supposed to have some sound. Do I have sound? No. No. Should I connect on the écouteur? Ici. Right. And so I'm just stopping this demo, and maybe we can have a look also on software that they are developing now. And there is this Noisy 2. Noisy 2 came after Noisy 1. It's basically a complex synthesizer using MP kind of. Do they have maybe video demos?
Let's dive in. Resonators are at the core of Noisy 2. A resonator is a sound source that generates and diffuses sound through resonance mechanisms reminiscent of the behavior of acoustic instruments. Noisy uses the organic and random properties of noise to excite and give life to these resonators. There are 3 resonator slots per layer, and each resonator has its own personality and can be modulated in many ways. Their levels can be balanced with a mixer, which is fed into a stereo filter module, and from there to the output section that lets you add warm saturation with the soft clipper and the feedback knob. Noisy 2 is a bitrimbal synth, meaning it features 2 totally independent sound layers. There are more than 1,200 main presets that comprise 2 layers each. Recombine any of the 2,400 available layer presets to quickly come up with new sounds in a flexible and playful way.
which consume usually a lot of CPU. And so we also help them to, even for the C++ compilation part, like deploying on different CPU and optimizing for each CPU and trying to discover with Faust, we can explore, we have some tools to explore the set of compilations that you can put on the Faust compiler, choosing between scalar mode, vector mode, different vector size, and you can benchmark all the different compilation and get the best choice of compilation option for each of the DSP. And then when you are at this step, you can produce the C++ and then even possibly compile for a given CPU. You use the auto-vectorization property of each CPU. So we try to help them to have the compilation chain as good as possible. And an interesting thing that, yeah. Okay. So maybe we can just connect. Should I connect myself on the? Yes. Okay. I have to stop my. Okay. Okay. So we have Pierre on the left and Victor on the right.
Hi everyone. Hi everyone.
So I was just before you came. Yeah. Enable my camera. Hi.
Yeah, we don't hear you very much for now, Stefan.
Actually, we don't hear you at all now.
Yeah, we were hearing you before, but yeah, Pierre, I can hear you very fine.
Me too. No.
No, we can hear you, Stefan.
Doesn't work.
Hello, hello.
Yeah,
no, fine.
yes.
Okay. So, well, just before you connected, I was showing your site with Osmose and a noisy project, and so it was just we had some remaining time before this one table. So maybe you can just present yourself and explain what we did together around the use of the Faust language.
All right. So I can start. So I'm Victor, one of the co-founder and CTO of Expressive. And Pierre is one of the is actually the first DSP engineer of the company. We've been working like 10 years together, and so it's been 7 years. We jumped on Faust language. Arche Collection was our first plugin that's been released like 8 years ago. It was all made in C++, and we were looking at this time a new language which meets better our philosophy and innovation culture at the company, because we are all using a lot MaxMSP for doing research. And Pierre so realized a benchmark to be able to find new language that meets all our expectation. and I can just let Pierre what was the result about this this benchmark I conduct to the first choice.
Yeah. So yeah, it was, as Victor said, it was 7 years ago. I think I started to hear first about Faust when I was working at IRCAM, like something like 10 years ago, before the Expressive journey. And I had it in the corner of my head. And yeah, when I arrived at Expressive, started to, this first plugin was already there, fully C++. The workflow, the process was a bit painful and long to do the DSP part. And so we are looking at about this more modular architecture. Max MSP is really at the center of everything we do in research and development for DSP synthesis project. And so, yeah, we were looking at the beginning, we were hesitating between Gen, because Gen was already here 7 years ago. But Gen has a main big limitation. It's hard to do like proper versioning. It's not a real language in that sense. And so, yeah, Faust, the main reason first was like the very compact context-specific language that as a DSP engineer, for instance, I'm not a C++ developer. I mean, I can write everything that is inside the compute function, but all the rest is just a pain and a waste of time for me to care about all this wrapping of actually the real code that matters for you when you do DSP. And the fact that Faust take care of that for you and remove all of that, and you can just focus purely on DSP algorithm in this very compact and very elegant syntax was on the main reason to go that way. And also, of course, like the power of the compiler with all the beautiful tools that Stefan was developing at this time, that you can target everything you want, compile for max, export the code. You just have this abstract code that can go to many different materialization, different technology, and without relying too much on it. And yeah, it was at the end what we end up was building a big modular synth in a way, using Faust with Max MSP as a finite target, then exporting like every function as module in the MSP environment. We have a culture at Expressive where the sound designer and the DSP engineer, they were really close together, and we try to imply the sound designer choice and the product choice very early in the development, and to work like this with like always the product side in mind. And yeah, Max is very, very awesome for that. So we end up building this big Max MSP library thanks to Faust. And now actually more and more sound designers are starting to use Faust in a more abstract way, not building DSP block low level, but using this big library that we developed called SynthLab. Now there is 100 of DSP module in it. And yeah, like one sound designer at least, the more technical one, is starting to use SynthLab more you can use Faust in two ways. You can do like low level DSP stuff, or you can use it as a modular synth basically, and just knowing the connection semantic of blocks, and you can basically use Faust as a patcher, and just calling. You end up just typing English and building your patch like that using the connection syntax. And yeah, I mean that's it. Huge, big choice. Very happy we made this choice early. Of moving to Faust. And of course, then as an engineer, of course, there is this functional goodness of the language that is very very nice to work with, like all this pattern matching, functional goodness that you can really think abstractly, build code base that are very modular, very scalable, easily. Yeah. I think that's all of that were the reason for that choice.
Okay, so hello, Pierre and Victor. This is Jan. You can't see me, but yeah, okay. So Pierre, you were the first Faust developer at Expressive in some sense.
Yeah.
How many people are developing in Faust currently now at Expressive? How many people are you, and how many people are developing in Faust?
So now we have one sound designer using Faust every day, and three DSP engineer working, including Pierre. So yeah, as Pessia, you made this choice, and now every product has DSP in Faust now. So yeah.
And are you using the standard Faust library, or you just rewrote everything from scratch, more or less?
At the beginning, we were like highly relying on it. It was also one of the choice at first because we were able to not start from scratch. At the beginning, like we started to use it as a base tool to start to build SynthLab. Also, like there is a lot of good code written in the standard that you can take a lot of inspiration of best Faust practice. You can basically learn Faust by reading the standard. I mean, I learned it like this, and now, yeah, now more and more we went out of it, and now SynthLab is completely standard free. We are not relying on it at all anymore. We have our SynthLab is completely independent from the standard.
Yes, and I understand the logic. And are you using a specific version of Faust, or are you using always the last version, or you keep because for we understand that your demand as an industrial partner is something different than what an amateur would require. You need some kind of stability, so to speak.
Yeah. We have our own Faust in the sub repo that is stuck and frozen to a specific version, and we do update very, very carefully.
Yeah, we have to choose.
Never use the last version you publish, but we are taking time and like building a lot of tests before to do the update. But this is Xavier's job. I cannot answer in more detail of all the stuff he's doing, but he's very careful before to update.
Yeah, we have a DevOps. So we're doing tooling around the Faust environment to match all the rules that we have in the software development in general. And so we choose to do the update when we have to do it in each specific product to be sure that there is no over collateral damage when there is updates.
Maybe you could say something about your project, if you can speak them publicly about how you are using Faust right now to do standard plugins to be deployed in DAW and this kind of thing, but you're also targeting embedded hardware. So maybe at some point you would like to use the same DSP piece of code written in Faust also on some hardware. So what can you say, if you can say something right now, about the fact of having Faust for the two different kind of targets?
So it was first the choice. I mean, we did several years ago was, of course, taken about that Faust is platform agnostic, so it's kind of future proof. So we know we began on plugin, but as it's platform agnostic, and of course we want embedded DSP and always thinking about other platform. I can't say much about that because it's just about research step. what I can what we can probably say is that Noisy was completely made in Faust. So really, like DSP was completely pure Faust. And I don't know if you remember, 3-4 years ago, we were working a lot together about the problematic to bypass DSP and CPU performance that we were facing. And so we decided in actually Noisy 1 and Noisy 2 are completely in Faust, and we decided to make a system above Faust to be able to like kind of audio graph that can run different bricks in Faust and can run also bricks, DSP bricks in other language, but mainly we're using Faust. But this audio graph can switch off easily DSP brick, which you are working on an on-demand function, but it's kind of preparation to target other platform because embedded platform, you have to be really careful with the CPU consumption, and so it's kind of the first step that we can talk about. Yeah.
Yes, and as you said, it makes sense to have a level when you can possibly combine with blocks that you develop with something else, or if you need convolutions that we can still not do in Faust. And well, it's always a practical approach to be able to combine at the C++ level. I have another question. You said something about Archie, which was your first development project. So at that time it was developed in C++, and now I think you have the new official version release on your site, which has been rewritten in Faust. Is it correct? Yes, the version which does the same as the C++ version.
Yeah, exactly. Yeah, we decide to refactor all the DSP code and move the CPB base in Faust-Based.
Okay.
And yeah, about CPU, everything sounds fine. The consumption is equivalent in the CPU consumption, and we probably and there isn't any audio graph in this version, so everything run in audio rate. There is no modulation at modulation rate, so it's really encouraging. And with all the work that you are currently doing about on-demand and observation, probably will be reduce the CPU and be able to be better than the actually CPB base.
Maybe we can say that you were the people trying to using the enable feature that we never publicly announced, because we know that it was somewhat limited, and even for you we tried to improve it as much as possible, even make it work in the vector mode. So the one way of compiling the code using the vec option. But even doing that, it was not enough, and we had different kind of problem emerging with by interacting with your use case, which was very demanding. So at that time, the conclusion for us was that it's probably not a good approach. So yeah, this was also a reason to push for the new way of doing that, and now we have on-demand starting to work. So we hope we can move on with you also on this specific issue.
Yeah, I must say that it's super important for us to have this kind of partnership with you because you have demands that you cannot even imagine. Being an industrial partner, it changed a lot for what the way you use Faust in unexpected ways for us. So it's super interesting to have such high-profile users for a programming language like Faust. I was wondering, do you plan to make us some demo or something, or because
we
nice
didn't
and
prepare anything about like demo.
okay, so maybe after we can. But you already show some
The
video.
best demo is noisy too, so
Yeah,
it's already on the market. So
Okay, and so what do you? So after this interview, so to speak, or we're going to present the Faust consortium or the plan for a Faust consortium. Can you tell us what are your, if you have any clear expectation about what the consortium should do for you, what would be useful for you?
So yeah, about firstly about the collaboration we had this 7 last years. We can say we are really happy because we can exchange really often. You both are really reactive, Romain also. So it's really important when you use this kind of tool and to have really often exchange about or as you said use case, which can be quite complex at sometimes. And so yeah, we want the consortium to kind of carry on that we are doing right now. So exchange industrial use case to be able to maybe prioritize your development roadmap and take account industrial subject that you actually really listen it. Like the on demand is really is probably a really huge evolution of Faust language. So we can also talk about the benchmark, the CPU benchmark that we have been discussing a lot because CPU is kind of a Pandora box. So you can optimize like things forever. But when you are industrial, you have to measure everything on daily basis to be sure that when you're developing DSP, you don't have any bad surprise about the CPU. And so exchanging the consortium can maybe kind of have several industrial with the same issue that we have, and maybe just prioritize things better. And also it's the consortium. Yeah, Faust is an incredible elegant language. I don't know. We don't know really if it's used a lot in the industry. And for us, it was important to say today, here we are using Faust. It's working. We think we release with Faust a great product. And we want to carry on to use it. And it's important to have a consortium to ensure the future and the development, all the knowledge base about Faust, the compilator, and all the community about this language. So yeah, I don't know if I answered the question, but
sure. Maybe looking at the audience, maybe someone has a question to ask to you. Are there any question for Expressivi? The way they work, they use Faust, or for example, how do you control that? So you test the CPU usage, so you will check that new version of the Faust compiler won't make regression on the CPU usage. How do you test also the audio quality of the product? And are you compiling in always in double or simple and double? What are you doing?
About the audio quality, we don't process any automatic test. We process it with this one and this one. That's the best machine ever. And yeah, we don't automatize. Actually, we thought about it last summer with Victor to do like automatic audio testing mainly for the presets, because from one version to the other to ensure that the preset of the last version are still sounding the same if you update an algorithm. But this is still something we have to work on the tooling. But yeah, mainly now it's for the audio we just the sound quality should be that everyone in the sound designer, product team, and DSP team are happy about the algorithm, basically. And about the CPU, what was the second question?
I was wondering if you compile always in floats or doubles.
I think this I have to. Xavier would need to be here to answer this question. We have a very complex compiling chain targeting a lot of architecture. I mean, we make most use of the compiling option. We try to really we rely on it a lot, and there is a complex compiling chain. I think maybe Stefan, actually Stefan better than me with your interaction with Xavier about the compiling strategy we had.
Yeah, at some point we developed this Faust-Bench and Faust-Based LLVM scripts that basically were compiling the same DSP with different set of Faust compiler option, just benchmarking the binary and trying to extract the best option. And yeah, this was part of the first part of what we can do to optimize. We had also discussion about things that we can do at the DSP level, like using tabulation in some cases where you can pre-compute things by doing tabulation. Obviously, you can also use FastMat, this kind of optimization that everybody does in DSP. When you want to go fast, you possibly use a faster version of some heavy log, tangent, mathematical stuff. And one third thing we did with you was to optimize for a given CPU. So it's not really a forced question anymore, but it was more C++ question. But at some point we had a tool chain. So you did the tool, the automatic tool chain to have compilation for each CPU version of Intel CPU. In the sense, you had depending of the generation of Intel, you had a better and better auto-vectorization stuff. And we help you, Xavier, I think, yes, to have this in place. So possibly, I guess you are still using this kind of DSP, Faust compiler, then C++ compiler. Each stage you can do optimization at each level.
Yeah, and most of the time about like real DSP low level stuff, most of the time we are very happy about what Faust already produce. I mean, the compiler is very smart. Most of the time it had happened a few times where we needed to go below what Faust had produced in CPP. I remember like for big modal synthesis engine with like a lot of parallel oscillator. for a lot of partial. In this kind of scenario, we had to go very low to handle the phase, like kind of by hand. But it has been like one or two cases in 7 years where we needed to go below what Faust output in terms of the compute function. So most of the time we're very happy about like just handling properly the compiler options, and it's most of the time the tools are here. Just need to use them to understand them, and most of the time we are happy about the performances. And if we are not, then we try to dig and benchmark better.
Yeah, and we think we have some more under the sous le pied, comme on dit in France, because of the on-demand branch that we have. We also have a new way of compiling delay lines that can improve in some specific case. Delay lines and scheduling instruction scheduling is also something that can allow us to gain something. Obviously, all these kind of improvements you see is again when you compile small DSP, and you don't see it anymore when you compile a very big. But for some use, like for some of smaller effects, it can probably still have a gain even in a pure C++ compilation thing. So we hope that when we will integrate all these new things into the official release, we hope that even this can be optimized a bit more. Yes.
Okay, so I think that we should conclude here. And thank you again for participating, Victor and Pierre. And super, it's still a startup, but it's a big startup. How many are you currently?
Between 30 and 40. Yeah.
Okay. So so we are happy to have you using Faust. So that's super useful for us also. So thank you.
Yeah, thank you for the invitation, and I'm sure we're going to talk together soon.
Sure.
Yes.
Yeah. Okay.
So
Thanks.
yeah.
Thank you. Thank you. Bye-bye.
So to conclude, these 2 days, which again, thank you for the organizing that. That was very, very kind. So we have this project of a Faust consortium. So the consortium is still a project. We would like INRIA to be comment on peut dire ça? To back up the project, to support the project. So we have still to convince them. Obviously, they will be convinced if we can show that there is a lot of interest from industrial partner. But we have this consortium project, but we have also created, and this is already created, a Faust association that Stefan mentioned several times. So it's also interesting that we discuss together. We will probably start to, you will be able to be part of the association from the 1st January or something like that. But it's also important that we discuss what we could expect from such an association. So the association is going to be for individuals, and the consortium is going to be for industrial partners. And Domenico just left, but it's a little bit like for the Faro. There is the Faro consortium and the Faro association that he mentioned that. Okay, so so the idea is that we need to ensure the future of Faust, so to speak, beyond our small persons. And, you know, we are still young, but not that much, especially me. So we need to think about the future. So the association, we have, I think that these 2 days show the quality of the member of the community. So we have to structure a little bit things better, and it will be better for you. It will be better for Faust, and we need to discuss about all this points. So the next step, the creation of this AFA, and this is done, but we still have to create the website and decided what the association is going to do, and the creation of the consortium, which will take some more months. So the association is called the AFA, which means Faust Association Faust. It's yeah, well, it's not very. It's what we call a non-for-profit organization in France, and so the purpose is to develop and promote the Faust programming language among users both in France and obviously internationally. And it's an association open to individuals. So we hope that you are all going to be member of this Faust association if you find that useful. The consortium will be open to companies, universities, and organizations in general. The idea is to give these big partner the opportunity to discuss about the future of Faust, to discuss about the roadmaps, and to gather some financial support to make some specific developments, for example, that this industrial partner will require. So you can start doing donations. So for so we have several level of contribution for the industrial partners. So the Faust Association will be a guest of the Faust Consortium. So you, as a member of the Faust Association, you will be able to have words to say also at the level of the Faust Consortium. And the membership for the consortium are not very high. Well, 1,000 euro is probably possible for university. I don't know, Alain, what you think, but yeah.
We have to discuss. We are entering a new world.
For instance, our budget is not certain. Well, it's, let's say, 5,000 euros per year.
Okay. Okay. Mm. Mm.
I mean, Ilia is a little bit biased, I think, because those numbers are, they come a little bit from INRIA, you know, I think they're really used to.
But in INRIA consortium, they are really higher than this.
Yeah, no, I mean, actually, like, this is like the light version that INRIA was suggesting. You know, I think they're very, used to work with very big companies, you know, like, that are like with hundreds of thousands of euros, you know, and so it's yeah.
But I guess that university have budgets to buy software, so why not? Because they don't have to buy Faust, so they can be member of the I don't know. What do you know of any examples of that in of being member of some consortium?
I remember we used to be members of the IRCAM forum. But it was less expensive than we gave
Okay. Okay, we'll see. Okay. So what else to say? That the organization of the consortium. So we have the General Assembly that oversee all the consortium operation. And that review the state of the ecosystem and formulate recommendations, approve the budgets, and set working priorities, and do all the coordination of the communication, the institutional communication. And then we have the more interesting scientific and technical committee that defines and updates the roadmap. That maintain the formal specification and the standards. So it will the official maintainer of what is Faust, so to speak. Maybe if at some point we have a third-party compiler implementation, it will be the organism that certify these compilers to be officially supporting the official Faust, and manage documentation tools and official Git repos. Voila, and so the scientific and technical committee already say all these points. So the members of this will have a technical lead appointed by INRIA. So the important thing is that if we have enough partner, then INRIA will support the consortium and maybe even pay for one person to be part of the technical committee. That would be great to achieve this kind of results. Obviously, the member of the MO team will be working on Faust, will be members of this scientific and technical committee, and probably representative of the one or two elected representatives from the consortium will be member also of this. So the process is that the initial so the scientific and technical committee will be really involved in the definition of the roadmaps, but we also expect suggestion from the community and via the AFA association in particular to contribute to this roadmap. But there will be a whole process of approving the roadmap and vote and this kind of. I hope it's not going to be too administrative, but otherwise not going to be very fun. But you know, well, if we start to have industrial partners, it's important to have a precise frame, I guess, about how to do all these things. Okay, so again, the whole idea is to start to structure the community and make this the Faust project pérenne, or at least nothing is really, comment on dit pérenne en anglais? How do you say? Sustainable, yes. And for the next, I don't know, 50 years? Oh, okay. 100 years? 1,000? Okay, so maybe now we can briefly discuss of the Faust Association. What, for example, just by curiosity, who would like to participate to such association, or who say, no, I don't want to be part of any of this stuff? Just
but it's
nobody's.
Like we should know what it means to be part of the Faust Association to actually answer the question.
Yes, right. Yes, but we still don't know what the. Well,
The value of receipt we manage among groups. That's first there is a chair, and there is the second most important thing is the schedule that the chair is proposing. So it's the meetings. So we've got the meetings from the core group, and we've got also meetings with the complicated. And what is important is that we got a sort of central point. It's the GitHub repo where people put issues, but not issues about the syntax or whatever, but more for discussing different points. And this is heavy. Every 2 weeks we have a visual conference with the core group where some people like me are mostly passive, but there are more active persons who are just taking all the issues one by one, and say what do we do with this one? What do we do with this one? Maybe we respond this one. Maybe this one is for the next version. Maybe this one is some kind of answer. Some questions have not been answered since 10 years. Okay, like we should add, a way to sync the theater together or something like this. But because they were complicated or nobody wanted to put energy on it, but at least we have a trace of all the discussion. So I don't have a mailing list and things like this, but this is more structured, I think, because all the working groups work the same. And it's maybe more work than we could order, but the fact that the schedule is made 6 months in advance, so we know what will happen this week.
Okay, yes, that's interesting, but it's a lot of work, and probably it's not. We don't want to do that much of work.
The visual conferencing we have every 2 weeks is just 1 hour, and after 1 hour.
Okay.
It's 1 hour, not 1 minute more. And if we put that on the program,
so this is a suggestion for the way the association work, to have a periodical meeting.
And people it's free. They are invited from by the core group. There are some people from the industry, some academics, and Stefan is also an invited member, so we can also invite experts. But the group stays small. It's not a group with 100 persons. Sometimes we are only 3, 4. I don't attend all the meetings, but the fact that there is also a small small in 1 page. It's not big. Who was there? What are the topics? What kind of decision in 1 line? And when I said that I was passive, for what we do, for example, the main active people are the developers in the process. But sometimes you got one guy from the industry with particular needs, and he has an important role, like
for example, the guy who was making the big sound engine for the AAA video games is Philippe Milo. He said, yes, we target now to export Unity games and Unreal Engine games to the web, so we need some particular things. So he came, he explained his problem, and then we started to add things to the specification, and that's led to all the WebAssembly stuff and support. So sometimes only one person can have a
huge impact,
an important contribution, and then what they say, okay, let's make some specification, let's make some implementation, and we need testers. We need people who wrote demos. This is some of my role. I was mainly in that kind of role. So yes, but there is a core group who are the brains of the things. This is you and Stefan for the moment.
But the point is that we want to enlarge this. This is why, even if you don't know exactly what the Faust Association is going to do, but I don't know what, for example, raise your hand if you would like to participate. If nobody raises its hand, if you would like to participate in some way, in a light way, to a Faust association because you care about the project that you are interested in. So raise your hand. Okay. Okay.
As I said, I participate to the web audio
to the web audio working group, Stefan also, but our involvement is not as important as some others.
No, but if you are a member of an association, it doesn't mean that you work every week, you have something to do. It's just that, okay, you say it's important to show that we are a structured group of people, and that's important for the future of Faust. So anyway, as soon as we need to develop the website and do some, so we hope that in January we can start asking you money, for example. Not very much, but yeah, you know, not to be part.
We want to be rich.
Do you have any reaction beside Michel about this idea of having a Faust association? Would you like to have a T-shirt with written, "Yeah, I'm supporting Faust," or a mug or whatever?
Yeah, and you know, also with the web standards, because this is the only thing I know well.
Ouais, okay.
We've got also targets, and the targets is let's make a stabilized version for this date, and then after we've got something a bit stable, you know, even when it is a frozen standard, it's just called a recommendation. We never say it's finished. And sometimes we've got also, you know, candidate for recommendation. That means, okay, it's stable. We don't touch the specification, but we're going to wait 6 months so that people test it. So people from the security will also check things and so on and so on. And after 6 months, we've got some experts that will evaluate the work and then say, yes, okay, that's good. And then we need testimonials. We do advertisements. We are very proud. We drink champagne. To take pictures. I go to the president of my university saying, hey, it's me on the bot at Seattle with the very famous people from the web. And like this, I can ask money to my president to pay some travel for me again.
Okay.
And yeah, so you know, because the fact that we've got some milestones with some objectives, it's also good for the motivation and the dynamic of the thing. It's not just let's meet and let's advance. It's better if you got a kind of program.
Okay, so Pierre?
Just a question / remark for the sustainability of the Faust project. I think without you, it stops. So do you think at some point that it would be interesting to hire someone and teach him the compiler as a, I don't know, as a guy paid by the association, like
well,
I don't know.
From the association, it's nearly impossible unless we have thousands and thousands of members that pay. But maybe for the consortium, yes,
yeah,
this is the idea.
Like basically the deal with Inaria is that if the consortium is successful, and that's what Jan said earlier, is that they would hire like a full-time engineer to work on Faust, you know, because like that's kind of the whole point about this, you know, like it's like, you know, and in order to do this, the consortium has to be successful and to actually become a thing, you know, like, you know, and there's probably not even like questions of money in the end, you know, like, but I mean, it would be better if there were a couple of members that actually pay a little bit something, you know, like, but but even without that, I think if the consortium actually becomes a thing, you know, and there are people who are parts of the consortium in one way or another, then I think chances that Inaria will actually do something, you know, like will be like pretty high, but that would be the idea, you know, like the idea is that Inaria would actually hire someone probably with a CDI to actually like work on Faust, and so there is more to win than to lose in the process, basically, you know, like.
So if we can show that the Faust Association has many members, for currently there is 500, more than 500 members on the Discord channel. So let's say that we have 100 members at some point, would be super nice. If we can convince then 10th company to on the page, on the Made with Faust page, there are many projects, small companies like the companies we saw of Chaos Audio, etc. So maybe they will agree to. I understand that they are starting, so they're not very rich. So even coming and financing to come here, it was expensive for them. But yeah, well, we need to. So the process that we are going to write to everybody, saying, okay, would you like this idea of Faust Consortium? Are you interested? Would you be part of it, etc. So even universities, and we'll see. That's. But it must be a community effort. And so we need also to understand as a community, if you are willing to make that effort, maybe also you ask some particular things to the association, a way to work that will justify your investment. So this is what we need to understand also. So we need to co-design this association. This is why we don't come with super clear ideas, because we want it to be a community effort, so to speak. So, so if someone has ideas, so for example, we mentioned the fact that it would be nice maybe to make, I don't know, online presentations, for example, or yeah, this kind of. Okay, so I want everything saying okay, but.
What can you do? Michel, do you have any video you could share, or would you like to make some videos about what everyone will do, blah, blah, blah? I can see yes, okay. Or maybe do a month, or I do the same with people that work with embedded systems. People who work with large frameworks like
FAUSTO.
Yeah, FAUSTO and FAUSTO, yes. So, from LSP with vanilla synthesis, maybe just demo it, say you want to use that, go there, like this. Like Alan just asked me to share things. This is what you need to make me pass for a bad student. We ask me things all the time. So I share some resources with him, and I asked him to share with me. So this could be shared with the community.
Okay, so maybe this is probably something we can quite easily do to maybe every 2 months.
I don't know if there are already videos on YouTube about this, but maybe there are existing material.
Or it can be the opportunity for people to make a video demonstrating. Yeah. And how do you see that? Because interviews is maybe also, well, you chat with someone, he asks questions, and he shows, makes some demos, and better done. So that's what you're saying. Okay, thank you. Okay, anyway, we wanted to give you this information. This is what we are going to try to do, and we will keep you informed of that, obviously, quite soon. Yes.
I have a question for the support of INRIA. Could you imagine it would be a support in terms of people? For instance, I imagine what the organization at IRCAM, for instance, for the SPAT, they have Thibaut Carpentier, who is a research engineer. And can you imagine someone being a research engineer at INRIA, part-time or full-time?
This is exactly.
Mm.
To open a position.
Okay.
To have someone. So it would be probably different from Thibaut because it would be like an engineer position. Yeah, it would like be an engineer position and not like a researcher position. But you know, like INRIA hires engineers and some of them are like fonctionnaires, and some of them are you know, just on CDI or CDD. You know, like, but I think the idea here is that INRIA would actually hire an engineer to support Faust. Yeah, and so that's.
But we have to convince them first.
Yeah, and it's
and this is the
like
point.
when we say INRIA, you know, like I mean, I'm INRIA, Jan is INRIA too. You know, it's just that there's a lot of political layers to convince about this. You know, and so we don't have like a formal like deal about this, but the understanding is that if we manage to put the consortium together, then you know, like the various layers will converge towards making this possible. Basically, you know, like that's so somewhat political. Okay. So yeah.
I think we should stop now, right? And maybe we take a... Yeah, okay. No, Michel.
I saw at the bottom of the first page from this conference, gender balance, and we were really bad. Just gender balance is at the bottom of the schedule, and
who put that?
So yeah, that was just an anecdote. So maybe we should bring women also in the association.
That's a very good point. Yes.
So, Francesco, guys, we would like to thank you and very much, and congratulations. And despite the fact that Soundmit was canceled, you were still able to maintain and volunteer to maintain the IFC. That's okay. And they were their own sponsor because nothing is free. So thank you again for that. And so we hope that FAUST will do some more product using Faust also.
More, because now we are 0 product Faust.
Okay.
1 is more.
Okay. Yeah. Okay. So, but Microcosmos, you are able to program it.
In the past, yes.
Yes.
But we have lost our first developer.
Okay. Okay.
We can work on it. Maybe it's better possible.
Okay.
With Lorenzo. The new
Lorenzo. No, I'm convinced that you need to program in Faust now, I hope. Okay.
So, can we take a picture of together?
Yes, sure.